We are now live in YouTube, so in preparation for the opening at 10 o'clock. Hi, Mr. Lei Hok Tio from Malaysia. You cannot hear us?
I can hear you now. Thanks.
Okay, you're welcome. So for those who are just in, you can try to say hi or good morning in chat so that you can see the messages there. Oh, Mr. Hiso Kim, you cannot hear us? You are still connecting to audio. So now, Hiso, can you hear us? Can you give me a sound?
Yeah, I can hear you now.
Okay, good. Perfect. Mm-hmm. The usernames, I think some usernames are in their local script, so maybe you can change it to English readable names.
Good morning, everyone. Good morning. Can you hear me clearly?
Good morning.
Good morning. Yes. Give me your thumbs up. Okay, great. Since we are approaching 10 o'clock, we are about to start our meeting very soon. Okay, now it's 10 o'clock. Good morning, Sawadee Krab. My name is Titi Tulayatit, Regional Expert of CCOP Technical Secretariat. I'll be your MC for this morning for the opening session. Sawadee Krab. Welcome Mr. Niwat Manikhat, Deputy Director General, Department of Mineral Resources, Royal Thai Government. Sawadee Krab. Dr. Yongchu Lee, Director of CCOP Technical Secretariat. Good morning, good early morning, and good afternoon for everyone. Welcome His Excellency Datuk Shaha Effendi bin Abdullah Asisi, Chairperson of CCOP Steering Committee, Permanent Representative of Malaysia to CCOP, Director General of the Department of Mineral and Geoscience Malaysia, distinguished guests, speakers, ladies and gentlemen, welcome to CCOP 2020 Thematic Session, Geoscience Towards New Normal in Future Earth. For the online Zoom meeting today and tomorrow. Now we're getting into the opening ceremony session. First of all, I'd like to invite Mr. Nivat Manikat, Deputy Director General of the Royal Thai Department of Mineral Resources, to kindly deliver the welcome address, please.
Thank you. Datuk Saha Effendi bin Abdullah Ashishi, Director General of Department of Mineral and Geoscience Malaysia, and Permanent Representative of Malaysia to CCOP, Chairperson of CCOP Steering Committee, Dr. Yong Julie, Director of CCOP Technical Secretariat. Distinguished delegates, ladies and gentlemen, Sawadee krap. Good morning. First of all, on behalf of the Royal Thai government to the Department of Mineral Resources, I would like to welcome all of you to the first online CCOP 2020 thematic session, Geoscience Towards New Normal of Future Earth, which will be co-organized by DMI and CCOP during 15 to 16 December 2020. Because of the COVID-19 pandemic, which had a great impact around the world, including the CCOP regions, CCOP has been adapting her operation carefully by organizing the virtual meeting to overcome the outbreak's impacts. Geoscience Towards New Normal of Future Earth is the theme of the session, which challenges and encourages all of us to update and contribute geoscience knowledge and information to cope with the changing world of new normal and future Earth. Geoscience community has now been facing a great challenge of the current COVID-19 pandemic, which has devastated community and economy around the world. Ladies and gentlemen, for the future Earth, demands of the geological resource for low carbon energy require our urgent action to secure the future of the human being. Moreover, global climate change threats are well recognized and responded globally by the series of international agreements or dialogues. Geohazard mitigation and urban geology are also main tasks for geoscience community around the world. To conserve the sustainable future Earth for the next generation. Ladies and gentlemen, finally, I wish this 2020 CCOP thematic session will provide fruitful discussion and outcome which benefits all of us to overcome the coronavirus effect in the short periods of time and create the future sustainable Earth for the long run. I wish all of you a good health and look forward to see you again face to face in the coming normal thematic session, which will be held in Vietnam next year. Thank you very much. ขอบคุณครับ
Thank you very much. Thank you very much, Mr. Nivat Manikat, Deputy Director General of the Department of Mineral Resources, Thailand. So next, I would like to invite Dr. Yong Julie, Director of the CCOP Technical Secretariat, to kindly deliver a special message, please. Thank you.
Thank you, Dr. DT, for introduction. Dr. Shahar Effendi bin Abdullah Jiji, Chairperson of the CCOP Steering Committee and Permanent Representative of Malaysia to CCOP, and Director General of the Department of Mineral and Geoscience, Malaysia, JMG. Mr. Nivat Manikat, Deputy Director General of DMR, Thailand. All the distinguished delegations, speakers, and participants from CCOP member countries, cooperating countries, and cooperating organizations. Very good morning. Greetings from Bangkok. Sawadee krap. On behalf of CCOP Technical Secretariat, I really welcome all the participants joining this thematic session of 56th CCOP annual session, and I really appreciate all of your valuable time in spite of we have very difficult and challenging situation caused by COVID-19. Due to the global COVID-19 pandemic, Thematic Session of this year is very special for our CCOP community. CCOP, in cooperation with the Royal Thai Department of Mineral Resources, DMR, organized this special online and offline. Actually, it is kind of a hybrid session, international meeting of this year's Thematic Session with the theme of the geoscience toward new normal and future Earth, to be held today and tomorrow from 10 a.m. to 5 p.m. in Bangkok time. I really appreciate the DMR for kindly offer and provide the meeting room of DMR's headquarters in Bangkok. Even with a very short notice, actually we have received a total of 47 very distinguished papers, abstract. 39 of them are oral presentations, and the others are poster presentations. Member countries have submitted 41 papers, and cooperating countries and organizations submitted 5 papers. I expect more than 100 participants to join and attending both an on and offline meeting of our Thematic Session of this year. I really hope that all the abstract and presentation today would be benefited to all those who would like to learn more about the updated geoscientific advancement and its outlook to the new normal and the future Earth during and after the COVID-19 pandemic. I'd like to express my sincere gratitude to all the authors of the papers and presentations today for sharing your valuable research outcomes. And also, I appreciate our CCOP Technical Secretariat and DMR team for their effort to make this meeting possible. I really hope we can meet face-to-face in the near future, maybe hopefully next year in Vietnam, or maybe in more recently in Malaysia, Malacca, for the steering committee meeting to further strengthening our relationships and international solidarity. Thank you all again for your valuable time and effort to joining this meeting, and hope you all stay very healthy and strong during pandemic time. Thank you very much. Thank you.
Thank you very much. Thank you very much, Dr. Yong Ju Lee, Director of the CCOP Technical Secretariat, for this special message. So next, I would like to invite the Honorable Datuk Shaha Effendi bin Abdullah Assisi, Chairperson of the CCOP Steering Committee, Permanent Representative of Malaysia to CCOP, Director General of the Department of Mineral and Geoscience, Malaysia. Please, sir.
Thank you, Dr. D.T. Tuliatit, for the introduction. Mr. Nivat Manikat, Deputy Director General of Department of Mineral Resources, Thailand. Dr. Yang Ju Lee, Director of the CCOP Technical Secretariat. Permanent representatives and heads of delegation of the CCOP member countries. Representatives of the CCOP cooperating countries and cooperating organizations, distinguished speakers and presenters, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, good evening, Sawadee, and greetings from Putrajaya, Malaysia. And hello, everyone. As the chairperson of the CCOP Steering Committee, I would like to express my warmest welcome to all speakers, presenters, and participants to this special CCOP thematic session with the theme Geoscience Towards New Normal and Future Earth, which will be held for 2 days from today, 15th December, until tomorrow, 16th December 2020. And this thematic session, ladies and gentlemen, was supposed to be organized as part of the 56th CCOP annual session, which was held in early November this year. However, due to the COVID-19 pandemic, this event had to be taken out of the annual session and conducted separately. Ladies and gentlemen, as we all know, the pandemic situation around the world is still very bad, with the number of global cases as of today approaching 73 million and global deaths almost 1.62 million. Our regional geoscience communities have faced great challenges caused by this pandemic that not only devastated our economy, but drastically changed our way of lives as well. Henceforth, our world will never be the same again as it was. Consequently, we must all adapt to a new way of life, the new normal, whether we like it or not. Therefore, this is the opportune time for us to discuss the roles and contributions of geoscience towards the new normal and the future Earth. Ladies and gentlemen, this platform is a very good opportunity for us to learn about the latest development in our geoscience community and exchange our thoughts and ideas with regards to this session's theme. This is the first time ever that the thematic session is carried out as a hybrid, both physical and virtual online meeting, and a separate event, as I mentioned just now, from the annual session. Even with such a relatively short notice, we have received a total of 44 abstracts. 37 of them are oral presentations, and the other 7 are poster presentations. Member countries have submitted a total of 40 abstracts, namely Brunei Darussalam with 1, China with 3, Japan with 5, Republic of Korea with 4, Malaysia with 10, Myanmar with 3, and Thailand is the most number with 14. Cooperating countries and organizations have also submitted 4 abstracts, namely Australia with 1 keynote presentation, Russia with 1, Petra with 1, and UKM with 1. Ladies and gentlemen, before we start the meeting, I would like to thank all the parties involved in organizing this event. We are truly indebted to the Department of Mineral Resources Thailand, DMR, under the capable leadership of their Director General, Dr. Somma Teshawan, and also to the CCOP Technical Secretariat under the esteemed Dr. Yang usually for the excellent preparation in hosting this virtual meeting. Ladies and gentlemen, as you may already know, my days with CCOP are numbered, as I shall officially retire from my public service position on the 3rd of January next year, 2021. Therefore, this will be my last time I am participating in this meeting as the permanent representatives of Malaysia to CCOP, as well as the chairperson of the CCOP Steering Committee. I am extremely fortunate to have had the opportunity to serve as the chairperson of this amazing organization for 3 years. I truly appreciate the help and support given by the advisory group, the technical secretariat, all member countries, cooperating countries and organizations. I hope that you will all pledge the same support to the upcoming acting chairman, Dr. Somma Teshawan. I believe he is a very capable leader and will guide CCOP in the right direction towards achieving CCOP's mission and vision. Over the years, we have shared many memories through our numerous cooperation programs and technical activities, of which I will always keep dear to my heart. I hope our friendship will remain strong and bond us forever in the true spirit of the CCOP family. Long live CCOP. Ladies and gentlemen, I think I have said my piece and paid my dues. As a final note, I wish all the speakers, presenters, and participants a successful and fruitful deliberation. Without further ado, I hereby declare the virtual meeting for CCOP 2020 thematic session officially open. Thank you.
Thank you very much, Datuk Shaha Effendi bin Abdullah Assisi, Chairperson of CCOP Steering Committee, Permanent Representative of Malaysia to CCOP, and Director General of the Department of Mineral and Geoscience, Malaysia. And now I'd like to take this opportunity to have the group photo session. I hand it over to Marvik, our IT manager, to take care of this. Thank you.
Hi, everyone. We would like to request you to turn on your camera so that you will be with us in our virtual group photo. So if you don't want to join us, so you just close your camera. So everyone's ready? We have 2 frames in our screen display. So we will have 2 group photos. So we will take 2 shots in each frame. Okay, ready? Please look at your camera and smile. Ready? 1, 2, 3, smile. Okay, one more. 1, 2, 3, smile. Okay, 2 shots. Ready? 1, 2. There is one black screen. Okay, ready? 1, 2, 3. Smile. 1, 2, 3. Smile. Thank you very much.
Well, thank you very much. Okay, even though we are a little bit earlier than our schedule, I think we better move on with our program because we have a number of papers to finish today and also tomorrow. So I'd like to remind you first for the general information for the presenters, really, even though this is the chairman of the sessions, to remind you again, but make sure that your presentation will be strictly 15 minutes long. If you speak longer than 15 minutes, we are afraid that we have to turn off your speaker and microphone. Right, now it's 10:20. Actually, today we have this morning session, and then we have the afternoon session. Starting from the afternoon session will be on 1 o'clock to about 5 o'clock, with the coffee break between 3 to 3:30 in the afternoon. And during the coffee break, we will have the video clip played on the on our special channel. So for now, I'd like to get on to the session 1 with our keynote speaker and also the Geology and Mineral Resources session. Our chairperson will be Dr. Young Julie, Director of the CCOP Technical Secretary. Then our co-chairperson will be Dr. Prinya Puttapipan from Mahidol University, Kanchanaburi campus, Thailand. So now I'd like to invite Dr. Young Julie and co-chairperson Dr. Prinya Puttapipan to take his place. And I'd like to hand over the session to our chairperson and also co-chairperson. Thank you very much.
Thank you, Dr. DT, for introduction. Good morning again, everyone. Young Jury from CCOPTS, and then my co-chairs. Please introduce yourself briefly.
Good morning, everyone. I'm Prinya Puttapiban from Mahidol University Geoscience program. Nice to be here. Thank you.
Okay, so we'll proceed our first keynote presentation. Today, actually, we do have a very important person who will give a presentation on keynote. The title of today's keynote is The New Normal for Geoscience in a Post-COVID World, Connecting Informed People with Earth. This keynote speech will be presented by Dr. Steve Hill. Steve Hill is a permanent representative of Australia to CCOP at the moment, and he got a PhD in 2002 in Australian National University, and then after that he joined Geoscience Australia for a long time, and then at the moment from 2018 he has been a chief scientist of Geoscience Australia. And his co-authors are Jane Song and Rachel Pradaski and Rebecca Motan and Chris Ruiz. Please, sorry, my pronunciation is not so good, I think. So please welcome our very important keynote speaker, Dr. Steve Hill.
Thank you very much. Just please bear with me as I just share my screen. Hopefully that has worked.
Yes, it's okay.
Yes? Oh, terrific. Thank you. Thanks for that. Firstly, I'd like to thank you for the opportunity to not only present at this very prestigious meeting, but also to present the opening keynote address. What I want to do in this presentation is really share with everyone, hopefully some inspiration and purpose about really the valuable role we can play as geoscientists for our people, our own nations, but also for the good of the entire planet Earth. And I think judging by the adaptive and tenacious way that this community has bound together to still run this conference, even in our challenging COVID times, I think is a great endorsement for just the sort of people that we are as geoscientists, which is exactly what the world needs in these challenging times. So I congratulate all of you for that. And I do wish you all the very best in being able to keep in good health and keep safe. So as I said, I'll be talking about really the change in the world and the role of geoscience in that. I have, apologies that I'm just trying to forward slides, but there is a bit of a delay. Hopefully. Okay, so this presentation is going to have three main parts. Firstly, I do want to just acknowledge a little bit about the context. I'll share with you some of the context for this year and the experience we've had in Australia. I think some of you are aware of some of the other things that have operated in Australia, but I think they actually say a lot about where we are in the world and the role of geoscience. And then I want to share and hopefully connect with all of you about really one of our greatest challenges as people, but then of course how geoscience is really vital for success with that greatest challenge. And that really is about an informed, trusted connection to the earth. We still have responsibility, and it's probably greater now than it ever has been. Then I'll give some examples of areas where we are trying to address that challenge and hopefully share some thoughts and ideas that may help all of you and build on what many of you are also doing in that space. So in Australia, we've had, yes, an interesting year with COVID-19. We've also had some other things happening in our country from an Earth system perspective. Earlier this year, we have been really part of one of the most severe and long-lasting droughts that we've seen in Australia. And that drought has had a profound effect on our well-being, particularly for sustaining agriculture, but also very important even for supplying fresh, drinkable, high-quality water for our population. And the other impact of that drought has been that our vegetation in our country has really been under a lot of stress, very dry. That drought, coupled with very hot temperatures in our last summer, led to one of the most severe and intense bushfire seasons that we've had in the history of Australia. And you can see some of the photographs at the bottom of the screen here are showing really some of the instantaneous magnitude and impact of those fires, particularly not only for areas that have been burned, but also for the air quality. I'm very happy to say that the photograph that's on the bottom right-hand corner of the screen there was one that I took just one day ago and visiting some of these areas, and I'm very happy to see the regrowth. And I think the regrowth of these forests and our country is a really good metaphor and inspiration for all of us to be tenacious, to be adaptive, and also look at how we regrow as a geoscience community in response to the year that we've had. In Australia, COVID-19 has perhaps not been as damaging as many parts of the world. We've in many ways we've had some advantage because we are an island country. We've been able to very much control our mobility into our country and within our country, but it has required some very strict and decisive lockdowns as part of that. But the impact seems to have worked quite well in Australia. We're certainly not out of it yet, and we continue to be vigilant. And I really do wish everyone all the best in their approach to tackling this challenge. But as I said, many impacts. I note that my figure of 1.4 million is now out of date. Things are changing so fast. I can appreciate it. We're now well over 1.6 million people that have lost their lives and many more that are unwell. And we've also seen people that have become more isolated, and we've seen a restriction in travel. And that restriction in travel, I think, is something that I want to build on, not only restriction within cities and countries, but between countries. And this meeting really shows that because of that restriction, we've missed out on the opportunity for face-to-face connection, but it is great to see that we are still meeting even in this format. The other thing, of course, the impact to the economy and prosperity of our countries, and in particular, people losing their jobs, hoping that they can still be productive and adding value to their countries. And really the changes that we're seeing in the workplace, people working more remotely, using technology more, the need for good hygiene and health. When you put all that together, one of the really big impacts for our society has been that uncertainty, in many cases frustration, the need for resilience, and the challenge to trust between people. And I really want to make sure that we acknowledge that, particularly because it affects our relationships, but it also potentially has an impact on our mental health and well-being. And certainly in Australia, that has been a major concern for us. And even in our workplace at Geoscience Australia, we've been very conscious of the impact that this year has had on people's mental health. Because of the restrictions of travel in particular, and also people's fear and need to be isolated, particularly at home, in Australia and many other parts of the world, 2020 has been the year of stay at home for many. And this has been, as I said, driven because in Australia we had fire and then COVID. And so people's safety was really a major concern if people were getting out into our country. In our country of Australia, we are a large country, but our population centres are very urban and very much clustered around the coast, particularly the eastern coast of Australia. So when people all of a sudden are restricted in their movement, we find that our 8% of population ends up having to be confined within a very small, about 20% area of our continent. What that means is that as people, and I think this is very important in Australia, but I think it's shared with many other places, that we begin to lose first-hand connection to country, to our own country, and of course, the geoscience that links into that country. If that's the case, then the important decisions and information about our country begin to have that evidence base eroded. This challenges our perceptions of parts of our country, particularly the areas that we no longer access, so the more regional parts of our countries, and particularly when we're relying on those areas for many of our resources. And that then has an impact on the social licenses of how we work with our country and our land. We also become less connected internationally, which means that there is a risk that we become more parochial or more locally focused in our concerns and particularly how we work with the planet. And that means that we miss that greater Earth perspective. And the fear is, as a scientist, that this impacts on making informed decisions and leaves us open to misinformation. And I think that is something that as geoscientists, we need to be very conscious of. So the summary there is that the Earth may change, but it continues to operate, and we still need to live with the Earth's resources, and our life goes on. The impact that we have with the Earth continues. And that means then that geoscience, its data and its information have never been as important as they are now. And that's something that I think we all share as a community, and particularly share with our messages to our government and our own and all of our people. And by providing that geoscience data and information, it is a way of providing connection to our country and the Earth, and the basis for better decisions, advice, and of course, trust for our people and our government. And I really feel that that's a strong uniting theme for all of us in the CCOP. And one of the things I look forward to in the next days of presentations is how we share information about that. So may I say welcome to country, welcome to our continent that we all live in, and welcome to our planet. And don't forget the importance of that connection. I want to say a little more about that challenge that we all share and perhaps towards some of the solutions. One of the really important bits is how we actually identify ourselves and define ourselves. And one of the things that we're very active in at Geoscience Australia is embracing a broad definition of geoscience for our mission. And that recognises that geoscience is is part of the Earth system. It includes geology, geography, many areas of environmental science, but it's more than any one of those. And one of the challenges we have with our geoscience community is really trying to awaken people that our community is bigger than just one silo of geology, geography, or another specialization. And the key here is integrating all of this into the science of the Earth. And that will change over time as our knowledge changes and as our needs and requirements change. Being more and more urban in all of our countries means that we sometimes forget that. And I want to say that no matter how much paving, concrete, asphalt that we pour over and cover the Earth and sometimes forget that there's a planet that we're part of and that sit under all that, and how many of the resources that we consume and how much byproduct we produce, we are still governed by the reality that we live as part of the planet. I think we're seeing in society that people are becoming at times more and more surprised about Earth processes that impact our lives, particularly things like geohazards and the importance for community safety from them. People seem surprised that we still have earthquakes, volcanic eruptions, tsunamis. And that's, I think, at times because we forget as a society that we are part of an active planet Earth. And geoscientists, therefore, hold an important key helping our community in that space. I think we can gain a lot of inspiration from people of the past and those people as they continue into our society. And in particular, in Australia, we have a lot to learn from our traditional owners. And the important thing is listening and learning from them. We have an Indigenous community in Australia that still strives to promote its connection to our land and our continent and our country. And at Geoscience Australia, we are very, very enthusiastic about making sure that we don't forget that and that is prominent in what we want to learn and connect into the future. These people have thousands of years of experience of living with Earth, and there's a lot that we can learn from them in that respect. This also has impacts for our social license. In Australia, a large part of our continent is held by traditional ownership and traditional owner communities. And also other big parts of our country are actually held by farmers and farm community. And for us to conduct our geoscience, it's really becoming more and more important that we do that in a way that is collaborative and in partnership with those local communities. And geoscience has requirements, social license. I want to say that it also informs social license through the information and the data that we collect. And I want us to remember that when we're working in different areas, because we're doing this by and large for the benefit of those people, and being able to share that knowledge, data, and have those conversations is something that we should all aspire to. In Geoscience Australia, we've brought in a new land and marine access group that really recognises those increased requirements for how we enter land and marine areas, but also give back to the community and inform future decisions. That information and transfer of data and information is also really important in education. And it's great to see there's a number of talks in this conference that talk about education programs for geoscience. I really commend those people for recognising the importance of that, because in actual fact, what we're doing is we're investing in our future, remembering, of course, that it is future generation that's going to be looking after our planet and potentially saving it. And the best way to do that, I think we would all believe, is through the best knowledge and information. And so I encourage us all to embrace that and to see that as really as a major achievement and priority for geoscience in this new world, particularly post-COVID. And not only at very junior levels, but increasingly into more advanced levels, and training people to be really the custodians of our geoscience as that moves forward. So what I want to talk about now is a little more about some of the things we're doing at Geoscience Australia to hopefully share some of that with you and give you some idea about how we're trying to use our science data and information in this new world to provide better connection to our country. One of the things that we really protect and adhere to is making sure that our data and information is open and freely available. That's not only to people in our country, but people through the world, through our website. We think that's important because the more that people can access it, the more that they can use it, therefore the greater its value and the greater opportunities we have to continue and grow that data. So although we could charge for it, the benefits of that fee are much, much smaller than the benefits of having larger engagement and people seeing the value and having access to data and information. So let's have a look at some of those examples. In Geoscience Australia, we've organised our work into 6 main impact areas as part of our strategy. And number 1 there is building Australia's resources wealth. This is particularly in the area of mineral resources, energy resources, and groundwater resources. This is really important to our economy, our prosperity, and our way of life, and is one of the most important export industries in Australia, and particularly with water feeding into agriculture. So it's not just minerals and energy that's part of that. Supporting Australia's community safety, I think we all know that geoscience is an important part of that, and we are our national responsible for monitoring earthquakes, tsunamis, and many other community safety geohazard type issues in Australia. I've mentioned water before, but that's actually such an important thing. We've also given it a separate strategic channel, and particularly recognising the interaction between geoscience and water. Oh, sorry, no worries. Creating a location able to, managing Australia's marine jurisdictions is recognising the importance of our offshore areas, and then looking into a location-enabled Australia is looking at positioning and satellite imagery. And then lastly, making sure that our people are informed about that. So just give some examples of some of our large projects, and then wrap up with a bit of a look to the future. One of our big areas of concern is if we are to connect to our country and our continent, is recognising that all of the things that happen in geoscience happen somewhere. And in recognition of that, we're working very hard to improve the accuracy and reliability of positioning for everyone working in Australia. And we're also working closely with neighbouring countries such as New Zealand in providing a network of improved ground-based, satellite-based positioning systems that will provide 10 centimetre accuracy across all of Australia, in many areas with mobile phone coverage down to 3 to 5 centimetres accuracy. And we want that information to be available to everyone, particularly through GPS, say in their mobile phones. And benefit then of making that free available is its impact will be greater, and it will therefore feed through into all sorts of industry opportunities in our country. One part of that positioning is also some of the new developments in INSAR, looking at satellite radar and using that to better detect vertical movement of our country. This is important for our engineering projects, but also particularly around community safety and detecting things like earth movements from landsliding, instability, and also earthquakes. And our aim is to now provide near to national coverage of INSAR on a regular basis. We feel that that will have a huge impact on how our country best uses this positioning information. The other example that I want to use is actually very relevant to a lot of what we've had this year, and that is what we call our Digital Earth Australia platform. And this is really using the decades of satellite information that we have, pulling that together into a data cube, and also making that freely and openly available through our website. So all of you can access this without any problems. And we have, as I said, decades of satellite information. And the important thing there is it's showing environmental and landscape change. And change has really been the theme of 2020 and will be into the future. So this sort of data in geoscience is of course very valuable. We're already using it for mapping changing coastlines, changes in water, changes in vegetation coverage, not only in Australia, but we have a project where we're doing a similar thing in Africa. And probably one of the most powerful examples is how we've been incorporating satellite data into tracking thermal imagery, into tracking our forest fires in Australia. And here we can see some of the near to real-time information that we've been able to provide on one of the fires from last summer near Canberra and how that spread. This information, this geoscience information, has to be trusted, and as a result, it potentially saves many, many lives. So this is an example of the new challenges and the new opportunities for geoscience. The last example that I want to share with you is really about the work that we're doing in resources, so minerals, energy, and groundwater. And the ambition here is to really pull together data and information that across the continent, but also integrating vertically. So three-dimensional, and actually as we bring geological time, four-dimensional representation of our continent. And the aim of that is to help us make better decisions about where we invest in further work and also where we invest in infrastructure and try to promote opportunities for new resources being discovered and used. And this is a project that we have called Exploring for the Future. This has already been operating for 4 years, where our main emphasis was across Northern Australia with large amounts of data acquisition, particularly geophysical data. We have more than 3 million square kilometres of geophysical surveys across Australia that have been collected in the last 4 years. And now moving into a new phase for a further 4 years, that is gathering all of these data sets, but now across Southern Australia. You can see that was where we previously worked in Northern Australia, now working across Southern Australia. And we have these two corridors, north-south corridors, where we're doing more detailed work to try and join the north and the south together. This is, by Australian standards, a very highly funded project, 125 million Australian dollars for the next 4 years. It's going to be exciting what we see at the end of this, where we'll have improved national coverage. I look forward to seeing where that takes us. One of the opportunities is with that sort of coverage, we're starting to move closer to an ambition of producing a digital twin of our continent and the offshore areas. A digital twin is a really exciting development in technology, and it's really more than just 3D model. It's producing a digital replica of, in broad sense, could be a living or non-living entity. In this case, we're looking at a continent and the geoscience that goes with this. And who knows, as we develop the skill for doing this, one day we may well be able to produce a digital twin of planet Earth. But in the meantime, we're working towards that ambition for the Australian continent and offshore. I'd love to see how that could work in with developments in Southeast and East Asia. But even shorter term, different components of the Earth system, such as sedimentary basins, catchment areas, mineral systems, for developing digital twins. There's quite a bit of inspiration out there. I'm really proud to say that the One Geology consortium that we are part of is dedicated to developing the science of digital twins. But there's also some terrific examples from around the world that I list here. And I look forward to the talk from Japan about the subsurface geology of Tokyo and how close that is to achieving becoming a digital twin. We have different projects in Australia that are also setting the foundations for digital twins. One thing I didn't say about them is not only are they, really a replica, but they then enable us to develop prediction into the future. And I think that's going to be an exciting development and a requirement of geoscience in the years ahead. Thank you, everyone. I'd just like to finish. In Australia, we often have acknowledgement of country that's linked to our traditional owners. And what I want to, for us all to think about as geoscientists is also when we meet with people to acknowledge that we're part of the Earth, and perhaps even acknowledging with our colleagues where we are all located in the Earth and what the Earth system is like for the point that we're meeting at. And so at Geoscience Australia, increasingly we're beginning to share as an acknowledgement and a welcome information about where we are in a drainage catchment, we are in a sedimentary basin, the local geology and the soils and how they've developed. And it's amazing how few people had realised that there's so much geology that is, and geoscience that is all around us and immediately under our feet. So hopefully, as well as thinking of the Earth, we can think about local settings there. So thank you. Please remember that we're part of a planet. Bring your best person to geoscience, and please help all work together to get that message out there. I thank you very much. Please keep safe, and I hope you all got something out of that presentation. Thank you.
Thank you. Thank you, Dr. Hill, for nice presentations. Actually, it's very impressive and give us very good insight and some outlook for the post COVID-19 situation. Actually, there should be many questions about your talk. One of the questions is that in the chat, I read some question. Which one? Oh, sorry. Okay, see, there are several questions. Geoscience Australia involved in the identification of the mineral resources, and they involved in promoting the development of mineral resources in Australia. So that is one of the questions from Malaysia.
Yes, yes. In fact, one of the really outstanding features of our geoscience in Australia, and I think it's also an important thing for all of us in the world, is how we all work together. And we're very proud of the way that Geoscience Australia is Australia's national geoscience body, but we also have our states and territories in Australia, and we work very closely with them, in many cases sharing data. In many cases, Geoscience Australia will incorporate the different state and territory data into our national production. And the key thing is that by working together, we actually maximise the impact of our work, and we also have different ways of funding further data acquisition. So I'm really proud that we learned about the power of collaboration, teamwork, and working together, and using that to maximise impact. And I must say that it's very much the same motivation that we have for really our support for CCOP. And I really admire the way there is a strong collaborative feeling in CCOP as well.
Okay, so is there any live questions which is not using chatting box? If not, actually, we are a little bit behind schedule, but may I ask you one just question in line with this mineral resources exploration? Sure. As you may mention, we have to go our Earth to be more connected and to our geoscience work to be continued. And then one of the most big issue at the moment is that the critical minerals, which is very important for the future Earth, and then zero carbon, the goals and everything. So many people believe that the critical minerals will be 5 times or more critical minerals will be needed for implementing our zero carbon world. So what is your, very briefly introduce about what is your the implementation plan or the project in terms of critical minerals in Geoscience Australia? Thank you.
Yeah. Great question. Yeah, critical minerals are certainly very high on our agenda. We think we have already a lot of existing opportunities in Australia for developing critical mineral resources, but there's also a very strong feeling that even the ones we know are the very end tip of the iceberg for the many other opportunities. And part of that is because Australia is so broadly covered that you can't see all of the underlying geology because of the cover that we have of sediments. And what we're trying to do is get better at seeing through that sedimentary cover and using that knowledge to better detect resources, but in particular critical mineral resources. And we're really working to improve our understanding of critical mineral systems, and making sure, especially even in our geochemical analyses, that we're improving our analytical data for the different critical minerals and their pathfinder minerals or associated minerals. So that's a very big part of it. In many cases, we're looking at things like rare earth minerals in Australia, but also the more conventional mineral commodities. Really good examples are commodities like copper and nickel that we have proven resources in Australia, but we think we have a lot more potential for discovery, and we know that those elements or minerals will become very valuable into the future. Copper is a great example, with particularly its ability to, the amount of copper that goes into things like electric vehicles is outstanding. So yep, we're very keen to develop those opportunities, and we have a number of government strategies towards improving our work in those areas geologically, but also improving the infrastructure and industry that sit around those critical minerals. So a very good question, thank you.
Okay, so I really hope that you have many good insight and some new technologies and advancement in geoscience. So I really hope that many CCOP member countries can also have opportunity to collaborate with the Geoscience Australia in the near future. Thank you very much for very nice keynote presentations, Dr. Steve. Please give him a big hand. Thank you. Thank you again. Okay, next presentation. The title of next presentation will be Happy Geoscience Edu, or New Geoscience Education System in the Time of COVID-19, which will be given by KIGAM, Republic of Korea, Dr. Yoon-jung Choi and Eun-su Lee, and Chanong Park, Samgyu Park, and Soo-jung Lee from KIGAM. Please, the presenter is from KIGAM, Dr. Yoon-jung Choi, please.
Hello, can everyone hear me? Hello?
Yeah, okay.
Yeah. Is my screen on?
Yes.
Okay. Hello, everyone. My name is Yoon Jang Choi, and I'm from KIGAM, the Korean Institute of Geoscience and Mineral Resources. So I'm so grateful to be here today to present our group's recent achievement in our new education system called Happy Geoscience Edu. So this is a new geoscience education system, which we are currently running in Korea during this pandemic time. So before we start, let me just briefly introduce our department. We are a geoscience education center in Kigang called ISGEO, which is International School of Geoscience. Founded in 2010 as an education center, we have all the facilities such as lecture halls and dormitories for foreign students to train and educate people from various backgrounds. So our education program can be divided into 3 different courses depending on who we are educating. So first is the globalization course, which is organized for geoscience experts to learn the newest research in their fields and to train foreign experts. The future course is targeted for students from like primary to high school students. So we teach them geoscience knowledge outside textbook to train them and possibly to let them become future geoscientists. And finally, we have the communication course, which is basically for the public. So we also train teachers and business companies and also general public in field of geoscience. So here are some photos of our past educations. And as you can see, all of our courses were basically face-to-face course, which is not encouraged during the COVID-19 time, where people have to keep distance among each other. And so we had to find alternative education systems to avoid this traditional face-to-face education format. So let me introduce our Happy Geoscience Edu, which is a new education brand that we created. So Happy Geoscience Edu contains 4 different courses: Happy Geoscience Box, Happy Geoscience Class, Happy Geoscience Talk, and Happy Geoscience Trip. So let me briefly introduce them one by one. So first, Happy Geoscience Box is a course that we send some random geoscience experiment kits in a box to families with children. The parents can follow the instructions which we included in the box. Instructions including like how to run the experiment and some scientific background of the experiment to guide their children at home. This course was created for families with young children who could not attend school due to COVID-19. So let's see the making of the Happy Geoscience Box. I hope you can hear the music. So that was our Happy Geoscience Box. And then we have Happy Geoscience class. So this is a similar course to our original future course, where we educate students to increase their knowledge in geoscience. Here, instead of the instructor visiting the school, we send our instruction videos to the teachers. So in classrooms, the students can follow the instructor in the video. So let's have a look at our video. Yeah. Then we have the Happy Geoscience talk. So this is an interaction course between KIGAM and the general public. The people can ask any questions within the suggested topic, and then the KIGAM's experts will answer their question. Thus, it's like a communication between KIGAM and the public. We try to make our answers short, precise, and simple so that anyone can understand easily and become more friendly to geoscience. All answers are posted on KIGAM's YouTube channel. Everyone is welcome to watch, but unfortunately, it's only in Korean. So let's watch the making of the Happy Geoscience talk. Okay, so that was our Happy Geoscience talk. And lastly, we have the Happy Geoscience trip. So this is a small group field course on UNESCO geoparks in Korea. Here, the education targets are the geopark commentators and also the local public. We restricted to local public because due to COVID-19, we didn't want to do it for the whole general people. We first run an online lecture of the background series of the geology. Then in small number of groups, they are on a field excursion. So let's watch our promotion video. So unlike the previous courses, this Happy Geoscience trip still involves partial face-to-face system. So next year, we aim to improve this by changing the field course to an online field course system. So let me briefly summarize our Happy Geoscience Edu. We have 4 different courses with 4 different targets, aims, and instructors. And as you can see from this table, so this is the end of my talk. Our Happy Geoscience Edu received so many positive reviews in Korea. and thus we wanted to share with you. So I hope our CCOP member countries found this system interesting and inspiring for the geoscience education in their country. Thank you.
Thank you, Yoon Jung Che, for very interesting talk on the happy geoscience. Actually, people really be very pleased to having some boxes or talks and some tours for the geosciences. I'm quite sure. And then, is there any questions for her talk on happy geoscience education system in KIGAM? Maybe there's no. Okay, yes, please.
Yes, a very nice and interesting approach in CCAM. And how many students that you can approach this teaching to them?
So in Happy Geoscience Box, we send the boxes to over 500 families. So for Happy Geoscience class, we are currently doing, how many schools have we done? 18. So 18 schools have attended Happy Geoscience class. Happy Geoscience talk, we have made 3 videos of Happy Geoscience talk of 3 different topics. And we are currently making another 3 videos at the moment. And Happy Geoscience trip, we also organized around 3 trip events. And hopefully next year we can do more, because at this time we had short time to prepare. So we could only organize 3 events for the Happy Geoscience trip.
Yeah, my short question. How many batches of students each year that you can cover?
For which course?
Yes,
Which course?
Which one?
the geoscience.
Just a talk.
Yeah.
Talk? Or, so for boxes, 500 families. Class, we had 18 class, so that will be around 18 times 30, around 300 to 500 students.
There's another question.
Another question, how do you identify which family or which class or which school that you're going to provide these geoscience box and geoscience projects?
So this year we announced, we advertised our events, and then we send it all the boxes to all the families who applied for our event. And for classes, we have been doing something similar before in our future course. So we have a list of schools that we are doing education, and the teachers from the school applied to us.
Thank you.
Mm-hmm.
Okay, thank you very much. I really hope that your geoscience, happy geoscience education system can be reached to the CCOP maybe for coming years, hopefully next year. Okay, thank you very much for your nice and very interesting presentation. Thank you.
Thank you.
One more question from YouTube.
Really?
Yes,
Okay.
one question from YouTube.
Oh, there's a live
Yes,
YouTube question. Okay.
Dr. Dean from Vigma is asking a question. Do you have budget for KIGAM to run the system?
Yes, we do have the budget to run the system, because we, as an education center, we have budget for education systems.
Thank you.
Yeah.
Let's move on to our next presentation, which will be chaired by the Dr. Prinya Japiban from Maidol University. Okay.
It's my talk.
Yeah. Your talk. Sorry.
Okay.
Just change. I inform you. Sorry.
So, hello again. Thank you, Mr. Chairman, because due to the time constraint, time difference between Russia and Thailand, and I was asked to present our paper first. So this paper Actually, I work with many co-workers as on the list, Professor Katsuo Sachida and a number of friends from Russia and from Peking University. The title that I'm going to talk is the syncline structures, the occurrence of the Permian, Triassic, Jurassic carbonate rocks of Kanchanaburi, Western Thailand. Next, please. The general content will include introductions, general geologies of the and review and update of the information, geology of the study area and geologic sections, stratigraphy and fossils observed. Then I will finish up with the characteristic of the rock unit in the areas and some conclusion and remark. Next please. First of all, I'd like to introduce you to the area I study is Kanchanaburi. You can see that is on the index map. The highest mountain peak is over 1900 meters above mean sea level. It's border Thailand and Myanmar borders to the west. Next please. And in the past, the geology that we based on is the geology from my former workplace, the Department of Mineral Resources. As you can see, the age of the rock ranging in age from Infer-Precambrian to Quaternary. And most of the rock units are lined up in almost northwest-southeast directions. And this is a general rock formation of the regions. Next, please. And our study area is located mainly in Sayok and nearby areas. The southern part is in Kanchanaburi province. And the northern part is part of the Thongpapum district. As you can see, the distribution of fossils, we observe there are different fossils and different rock formations. When you look at the maps near the oblique truss and right lateral fault to the eastern corners, northeastern corners of the areas, there has been report by many workers, including Bunopat in 1980s, about the occurrences of the Triassic rock unit in the areas, which is quite puzzle to us why these Triassic rock units occur in such a manner. And further study by the Department of Mineral Resources member and including Henry Fontaine, the late Henry Fontaine, who is the CCOP technical expert for sometimes. They record a lot of Jurassic fossils in the northwestern corners in the carbonate rock. As you can see, most of the lower Permian and middle Permian fossils are concentrated in the southeastern corners of the areas toward the town of Kanchanaburi, and the other lower Permian and middle Triassic fossil found in these carbonate rocks in the outer boundaries, outer flanks of the areas. And we can see the Triassic rock units that used to be mapped as Permian limestone, right near the bottom half of the study areas. And these rock units are mainly dolomites and dolomitic limestone. And we found the uppermost, the northwest corners is the Jurassic, occurrences of the Jurassic limestone. Next, please. Now, if you look at the rock unit in the terrains of the study areas, we have some inferred Precambrian rocks, high-grade metamorphic rocks, hidden underneath most of the rock unit. Yeah. Which one? Oh, it's okay. So you can see it's reflected. The green. You have the green one? And oh, okay, and if you look at the rock unit in the area, you can see the carbonate rock in the areas that we are not mentioned of is the Ordovician limestone, which are in green color to the northeastern corners of the map, and the orange color is actually the Permian limestone. The purple color is the Triassic carbonate, and the pale green in the northwest is the Jurassic limestone. Next, please. Now, I'd like to show you the general orientation and the cross-section of the areas. You can see our XY, the first cross-section, the XY is almost in the southeastern part of the terrain. It is the case of the so-called syncline structures. The orange color is the Permian, Midland Permian limestone at the lower part, lower Permian, Midland Permian, and the upper Permian. And after the Permian, upper Permian, there is a break. And then we have an unconformity from the upper Permian to the purple, the violet colors. You see the purple colors, that is the Triassic. Okay. Now I have another two. Thank you. So you can see this is the general stratigraphy, and in the rock columns, you can see the distribution of different rock units together with the fossils being identified. The lowermost part is lower Permian, and then we have Midland Permian, and then we have a long break, a substantial break and unconformity in some area in the flank of the pole of the syncline. There seems to be a disconformity. In the case of the fold, we have an angular unconformity quite clearly. And then the purple color is the dolomitic limestone. And then we have the bluish color at the here. The bluish color is Jurassic. Now the characteristic of the rock sequences, you can see the lowest sequence advanced purple carbonate rock, and this is recognized by light brownish to gray brownish clastic rock, and then with fragments of fossils, and then transform into the thin bedded chert-rich layers with a lot of index fossil fusarium. And the age of these rock units are early to middle Permian. If you look at some of these rock formations, you can see this is the short layers, which help us a great deal in identify the formation and the orientation of the rock unit. And this is these are the general index fossil found in the rock unit. The second rock unit is Wat Tham Sua down carbonate rock. This is an upper, middle to upper Permian limestone. It is fresh, relatively pure limestone with a lot of fossils, mainly small foramen of has been treated as the index fossils, middle to upper Permian. And then after that, and this one, you can see some very limited lenses, nodules has been observed. And right at the unconformity, we can see some of the paleokarst landform. This is, we believe, this is the karst of the upper Permian before overlying by the Dolomite Triassic nearby area, next to this area. And this is the general fossils of small foraminiferous. And this indicates the age of the uppermost Permian, upper part of the uppermost middle Permian. And the other one is the Triassic, Khao Sam Chan carbonate rock approaching the Mahidol campus. We have been puzzled for so many years about this being not a Permian rock. But this year we have a chance to prove it. It is not a Permian. It is actually a middle Triassic dolomitic carbonate. They have different type of environment of deposition and also different species of the foraminifera, small foramen. The additional information from Triassic fossil from Henry Fontaine, the late Fontaine, and the deep Suti-Thorn, the DMR members, indicate the Triassic carbonate rock extend toward the north of the Kanchanaburi or Sayok area in Phuttakhien. And the Jurassic rock are mainly carried out by Henry Fontaine and Suti-Thorn and his team. They are actually exposed in the northwestern part of the area only. And it is quite young, and which means the area remained covered by ocean during the Jurassic period. And these are some fossils and some small foramen and algae from this rock unit. We do not have a clear relation between the Triassic and the Jurassic that we are carrying out our mapping during this semester. In conclusion, the stratigraphy, beddings, orientation, and the fossil assemblages observed from the Permian, Triassic, and Jurassic rock unit in the study area clearly indicate a big plunging syncline. It plunging with the axis in the northwest southeast direction with a very gentle plunging toward the northwest, toward the Thongpaphum district. Next page. Yeah, okay. And then the unconformity has been observed between the Permian and the Triassic. Next page. And although it is a great difference between environmental issues of the formation of the rock units, we are still working on these issues. The actual geologic settings and the Jurassic carbonate rock is relatively obscure, and we are carrying out of this problem. Next please. Our last conclusion is the effect of the later tectonic deformation events on this carbonate sequence are essential and being worked out, being assessed. Thank you very much for your kind attention.
Okay, thank you very much, Dr. Prinya. Sorry for I have some misunderstandings of introduction. I have to introduce him, his presentation. Anyway, thank you very much. Very nice presentation. Is there any questions on his talk? Actually, we are a little bit behind the time, behind schedule, but still very quick question. Okay, can I have one very quick question about? Looks like there's many the fossils found in the Kanchanaburi area, the Triassic, Jurassic, and Permian period. So, is there any big fossils like dinosaurs have been found in Kanchanaburi area? Because there's some sediments, so maybe could be.
Yes, thank you very much for your questions. Actually, I did mention about that the Cretaceous red bed of the kangaroo bird. It is the non-marine red bed, and the same share the same age of the Kolat area, Kolat sandstone. And we expect to find some trace of fossils of dinosaur, and we haven't found any yet. Maybe we need to work harder. Thank you.
Okay, now I would like to hand over chairmanship to Dr. Prinya. Please proceed for the next presentation. Thank you.
Okay, thank you very much. We have, I think, 3 more presentations to go in this morning sessions. Our next session will be on the topic of stepping up promotion of Malaysian geoscience through digital platform in the new normals. Our authors, including Muhammad Mataza Mani and his team. And this will be presented by Muhammad Mutaza and Masi. You have the floor and 15 minutes, please.
Okay, thank you, Mr. Chairman. So now, Assalamualaikum and a very good afternoon to all our audience. Ladies and gentlemen, now I would like to present about the stepping up promotion of Malaysian geoscience through digital platform in the new normal. So this presentation created by co-writer Dr. Norbert, Mr. Anwar, Mr. Rahim, Mr. Rahim, Mr. Zamri, Dr. Dana, and Professor Dr. Chazis. Sorry. Sorry. First of all, the Malaysian has a unique and rich geological diversity where highly potential to be developed as geotourism destination. In the Malaysian Development Plan, we call the RMK11, Department of Mineral and Geoscience Malaysia, and the Ministry of Energy and Natural Resources, KESA, are responsible to implement the related geoheritage and geopark project. And one out of scope in this project is to develop the geospatial data, especially about the geosite through the digital platform. So geosite is a location that has been identified as have high geological heritage value such as scientific value, aesthetic value, recreation value, or culture value, comprising geological diversity such as rocks, minerals, fossil, geological structure, geological process, landscape, landform, and so on. And started year 2019 until now, GMG collaborate with Malaysian Geological Heritage Group and a National University of Malaysia UKM has developed a system using the apps to promote about the geosite, especially in geopark area, like Langkawi UNESCO Global Geopark, geosite in national geopark areas such as Jerai and Kinta Valley Geopark, and also to promote high potential geosite data in Malaysia. In addition, all this information about geosite will be transformed to digital using apps system and also use proper GME server data management. Next is about the objective this presentation. First, to promote geosite or geological site for the stakeholder and the public at national and international significant, ONV, we call understanding national value. Second is as an outreach tool for geo-education, even the student, researcher, or public can be accessed digital information through the apps. Third, to propose data management and sharing among GMD officers, stakeholders, and federal or state agency for one of the effort to identify site area with potential to become national heritage. Next, to sharing that data and implement for land use planning, especially tourism industry activity. And the last, and an innovation in GMG related IR 4.0. Next, firstly, the apps known as My Geotapa. My is stand for Malaysia, and Geotapa is stand for geosite. So the main thing here, this apps using data model based on the schematic determination standard MS 1759 2015 for geodatabase development and data capture. And we target these apps for geotourism, education, and research, and will be hosted in Gamma, maybe first quarter year 2021. Gamma is a gallery of Malaysian government mobile application. It's controlled by related Malaysian agencies called Mampu. This is slide. This slide is show demand. This app is considerably high first vision prototype apps filed by Geotapa. These apps can be accessed through GMD website official. This is a overview the methodology to develop My Geotapa apps from beginning to the end process. Started by collecting inventory data, discussion on input, data availability, and verification through GIS platform, and data serving in proper GMD server data management, and lastly, the data are able to be accessed by user through My Geotapa application. This slide show the what I'm saying previous slide. They mean show the schematic data My Geotapa follow the Malaysian standard geographic information. It means the geometric feature and attribute code MS 1759 or 2015, which is where the base data from My Geotapa apps use historical site category. For example, use field code number 8 until number 32, related geological diversity, because this is very important, especially to verification and data management, or classified geodiversity data such as rocks, mineral, fossil, geological such and so on. Next is the table of distribution in percentage of sites that have various geodiversity in each stage. For example, based on previous data, Johor State they have 43 high potential geosite. From that, there are 36% dominantly geosite are landform category. Okay. This slide shows the description of each information group provided for end user in my geotapa application, such as name of geological site or geosite. This is geological uniqueness, location, GPS coordinate, age instead of geological age, and geoheritage value described as scientific, location, aesthetic value, and the last short description, some explanation on the site in layman terms. So next, this is interface, the second vision of my geotapa. This slide show the item in my geotapa application contain glossary, then tutorial and how the use apps, definition of geosite, selection of site in Malaysia, geosite or geodiversity, okay, and then point location on a map for each site, and the advanced tool in my geotapa. And the last show the list more high potential geosite in Malaysia. The next slide show one of the geosite location in Labuan, Sabah, is East Malaysia, known as cool bedding at Tanjung Layang-Layangan. So we can explore geosite image, direction map, and also point location maps. So in my conclusion, geosite can be used as natural resources-based tourism product or geotourism through digital platform like My Geotapa apps to generate income for the local community area. And these My Geotapa apps also can be help the tourism activities such as a geo guide training in Geopark area or geosite information area through digital platform. And for the future planning, maybe geosite area not just explain the location description, but consider how to visualize geosite area or use 360-degree visual tour technology. Maybe we need high expenditure budget because the high impact to sustain development area and give experience for user. And lastly, application of digital technology in COVID-19 pandemic, such as use My Geotapa apps, can help tourism industry activity to promote geosite and geoscience activity related geoheritage and geopark program. So I think that's all for this presentation. Before I close this session, I would like to share short video about My Geotapa. Can I share?
Yes,
Okay.
very shortly.
Okay, right.
Not 1 hour.
Actually, only 1 minute left. Only one
Okay.
minute.
Can you see?
No subtitles.
No, sorry. I want to show how this app function for the user. This is the list of geosite in Peninsula Malaysia.
Okay, thank you very much.
Really? All right.
Very nice
Okay,
talk.
thank you. All right.
Thank you.
Really can say. All right. Okay, thank you. That's all.
Thank you.
All right.
So as we run out of time, if anyone like to ask questions, please keep a chat questions and Muhammad will respond to your questions later on. Let me move on to the next topic. There will be two more topics. Both of them are from Thailand. The first one, the growth media with terracotta diatomite tablet for a new future living trends. The paper is from SCG Thailand. Benjawan Thep Satitsin and her colleagues going to present this topic. Kun Benjawan, you have the floor.
Thank you, Chairman. Good morning, and thank you all very much for coming today. My name is Benjawan Thepsitsin, and I am Assistant New Mineral Business Manager from SCG Cement Company. I am pleased to be here today to talk to you about growth media with terracotta diatomite for new future living trends. I will start with agenda of this presentation. This project has the four topics. First is background and objective, and second is production state and research, and the third is preliminary marketing, and the last is conclusion. Next is the background and objective. Before I start, I would like to just give you about background information of this project. During the peak of the coronavirus outbreak that everyone in Bangkok discovered at last, one new hobby in their solitude is houseplant trend. They have become a certain trend, especially during the lockdown, as people are restricted from leaving their home. Many have turned into planting to keep them busy. Now, more than ever, people are into houseplants, even those that have no experience in planting or the less gardening. Type of people suddenly want to plant. Perhaps we can say planting has now become part of the new normal lifestyle, and it is probably something that will stay for long. This slide explains about what is a growing media. Growing media is important for support nutrients and moisture for plants in which they are grown. An understanding of material for growing media is important for encourage root health and can support plants. Growing media are materials that plants grow in and specifically designed to support plant growth and can either be a solid or liquid. Different types of growing media are used to cultivate variant plants. Growing media may also be known as growth media, culture medium, or substrate. For the requirement of growing media is to provide encourage of growing media, to provide encourage for the plants, to provide adequate air space for roots, respiration, to hold sufficient available water, to hold sufficient available nutrients, and the last to be free of plant pathogens, pests, and weeds.
When you want, can you share your slide? If not, share in the screen.
You don't see my
Yes.
slide?
We can see from our side your slide. We can see here.
Oh, okay.
I share, but
Okay.
but you don't see.
Can see. We can see.
Oh,
No
okay,
problem.
Okay.
Okay, thank you. For the objective of this presentation is focused on to find out new business opportunity. To second is utilize the storm mine area to the most effective. And the last is create high value product and innovation of diatom mine. This slide is explain what is diatom mine. Diatom mine is sedimentary rock that is mainly composed of the siliceous skeleton of diatom mine. For physical property is high porosity, high permeability, a very low density, and excellent absorbance. For chemical property is silica oxide content. Specific gravity is 2. Porosity is more than 80%, but lower if impurity present, and bulk density is 0.2 to 0.4 gram cubic meter. This slide is show the location of diatom mine in Thailand. Diatom mine is mainly found only in Lampang province, but its physical chemical property are not good enough for wide use unless it is modified. For SCG area is located in Nam Cho, Meta district, Lampang province, northern part of Thailand. In this area, there is storm mine deposit in Lampang basin, which is the second largest inland tertiary basin in the northern part. This slide is show the outcrop of diatom mine in SG area and other area. It has detected more than 20 meters, but they use for filling in area and not for in factory. And this slide is show that mine in SG mining concession, it has reserved more than 2 million tons in mining license and more than 10 million tons in SG lands. The top per is laterite and clay about 2 or 4 meters. The diatom mine is under, and thickness is about 12 to 26 meters. Next is production state and research. This production state is summarized as flow chart. It has 3 T states. The first state is molding process. The first stage is morning flow state. In this state, we use low-grade diatomite powder and spray with water in bending machine. After the material can mold, the machine will feed all material to the molding machine. After 2 hours, we'll get a diatomite topper. The second stage is the burn process. In this study, we use the temperature about 700 to 1200 degrees Celsius, about 8 hours. We found the suitable temperature is 1000 degrees Celsius, become to terracotta diatomite topper because of diatomite is look additive brown color, oily and not melt when wet the water. The last stage is sieving process. For separate site, we have 3 sites. Site S is 2 to 4 millimeter, and site M is 4 to 8 millimeter, and the last is site L is 8 to 16 millimeter. You can see we have the 3 sites for this product, and you can use for the decorative penetration. This is the show is water absorption test of SCG LWA and diatomite and Japanese soil. The water absorption of diatomite is 10 to 14% in first hour. After 1 day, it is decreased to the 4 to 11%, and after 2 days, it decreased to 2% to 10%. After the test can summarize the best of water absorption is Japanese soil. Second is diatomite, and the last is LWA. Next is the preliminary marketing. This is a slide show customer feedback in 3 groups. The first group is cactus plant group. Requirement of media in this group is brown color, granular shape, and indicator for watering. Second is hydroponic group. This group need brown color, clean granular shape, neutral pH about 6 to 7, and long lasting and reusable. And the last group is orchid, high-end orchid. Their need growing media is water absorption, granular shape, and root creeping. This is a show Orchid Festival event in locally province and Thai in action event in Bangkok. Our event is for introduce product and give sample to customer for use and get feedback later. And the last is conclusion. This product is organic natural product with no chemical additive, high silica, high porous for water holding, high absorbent, non-hazardous mineral, long lasting and reusable. And the second is this product is good indicator because of change color when water to your plants. And the third is provide dryness and aeration for healthy root growth, has the ability to absorb water while spending nutrients to your plant root And the last is utilize low-grade diatomite for high-value products. Thank you for your kind attention.
Thank you very much for very good presentations. Does anyone have any questions? It is an interesting paper. Yes, please.
Thank you very much for very nice and interesting presentation on growing media. Actually, it's a quite new, not very new, but very interesting growing material to adapt it to the market. So my question is that it is very good to have a diatomite to use for the special purpose, but what is the market size, and then what is the revenue you can expect for example, you have to mining and then some processing, and then if you go to the market, the price will be will be quite. So what is the market size for that growing material, growing media, and then what is the expected revenue for ton, something like that? Do you have any that kind of numbers? Thank you.
For the market side, import and export in this material about 190 million baht.
Dr. Somsak.
Thank you very much for your interesting presentation. I'm very impressed with your product. Can you hear me right? I'm very impressed with your product. I have two questions. The first one is for the diatomite product itself, does it has any fertilizer property in the material that provides some fertilizer for the plant? And the second question is, can you provide some example for me? I would like to try it. Thank you.
For the fertilizer,
ไม่แน่ใจว่าในตัวของมันเองอ่ะมีคุณสมบัติเป็นปุ๋ยอยู่ด้วยหรือเปล่าคือมันให้แร่ธาตุกับพืชได้ไหม
มันเป็นสารปรับปรุงดินนะคะที่ต่างประเทศที่ออสเตรเลียเขาจะใช้เป็นสารปรับปรุงดินนะคะ
English please
how to say in English in overseas in Australia they use diatomite for mix the soil for the
improve the soil condition.
To improve the porosity.
To improve the soil.
Is concerned pH of the soil. The pH.
So only for soil condition. So it can become a kind of soil conditioner in some case.
I have a short question about the. Have you ever compared your product with the perlite pellets? You know perlite?
Yes, I know perlite.
Yeah, you compare the uses of both perlite product and your products. Which one you recommend?
For the perlite, I never compare with perlite. I compare only the Japanese soil and lightweight aggregates because of the same, nearly same the material.
Okay, thank you. Yes.
Actually, if you go to Mammoth mine, there is a kind of something what they call leonardite. Have you ever heard for that? And SCG, many times visit over there. I think it is a good place for you to compare between your data mine, which is also maybe some data mine also in Lampang as well. So maybe if you compare these two kinds of the soil conditioner, then maybe you can tell us much more. And it's a good, interesting paper as well. Understand?
That is the suggestion, recommendation. Thank you very much, Professor Panya. Thank you very much for Kun Benjawan. Very nice talk, very informative. Thank you. We have another paper actually as scheduled, but because of Kun Kitty is unfortunately cannot be with us by unexpected circumstances. So we going to adjourn our morning session and then we all go for lunch and then we come back at 1 o'clock, 1 p.m. Okay, Bangkok time. Thank you very much for your attendance and we'll see you after the break, lunch break. No announcement? Any announcement, Secretary?
No, yes. Thank you very much, Mr. Chairman and co-chairpersons, Dr. Yong Julie and Dr. Prinya Puttapiban, for being our excellent chairpersons and co-chairpersons for this morning session. We're just a little bit late, but anyway, as I made an announcement in the chat, encouraging all the speakers, presenters, to please kindly complete your CV form and send it to us. We still are waiting for a lot of CVs for our chairpersons. Otherwise, you will not be introduced in our meeting. Well, thank you very much and see you at 1 o'clock Bangkok time. Yes.
Hello ทำได้ดีมากโอเค
Test 1 2 3 Okay, good.
Where can we get water?
Testing. Oh, yeah.
Testing, testing. Ah, kenapa? Sini, sini, sini. Zul, cepat Zul, nak start dah.
Kena buat bluetooth dulu.
Oh, jadi dia mau tekan apa tu dia keluar masuk balik. Oh.
Dah. Kalau tutup kat sana.
Okey, besar. Besar kan ni? Besar kan ni?
Boleh dah tadi?
Test, test. 1, 2, 3.
Tu tukar. Ha tu? Dah.
Test.
Tengok setting ni. Sama tak?
Merabit, can you hear me?
It's okay.
It's
Now
okay
it's now it's okay.
Okay. Kena di sini ya, baik. Ya.
Abang kena stand by as you are.
Ya, sebab saya
Jangan buka.
tak memang tak tukar no. Tapi saya session chairman ni sampai petang ni baik ni.
Kalau tak ada orang buka tak ada apa.
Ha? Okey.
Yang pukul 3 tu apa punya? Yang admin email tu.
Elvin tu dia ikut masa ni.
Kedua. Kedua lah.
Ha.
Satu. Okay lah. Abang stand by lah. Ya, lepas kita.
Director summary.
Yes. Yes.
I just sent you the 3 of the CVs of the speakers for the afternoon session. I only got 3 people.
By WhatsApp or not? By WhatsApp
through your WhatsApp.
Okay. From Russia. Okay. From Myanmar.
Dr. Tawachai.
Hi.
Hi. As our agreement through Dr. DT, you will chair for the second session.
Yes, right after the break.
After the break?
Yep.
Okay.
ที่ยังไม่รับแอดผมนะหรือเปล่าวะเดี๋ยวเมื่อกี้ผมพยายามหาอยู่
Thailand ini dokter apa nih? Ini. Oke.
New schedule, right? Hi, I'm Pizza.
Sorry, yeah. Hello.
Hello.
Thank you very much for your contribution.
Nice to meet you again. So, Dr. Fiza, in Russia, in morning or what now?
Yes, it is.
Yeah, early morning, early morning. Just wake up.
Yes.
So what time is it in Russia now?
Well, actually, not early. It's 9, but I have already my deals with my daughter and so on. So I have some daily routine, and then have just come back home.
So your talk will be the second one in this afternoon,
Yes,
all right?
yes, thank you very much. Thank you.
Hello, everyone. Hello again. Sawadee krap. Good morning, good afternoon. And welcome back to our CCOP 2020 thematic session this afternoon. Since we are having quite a lot of presentations this afternoon. So for the session, afternoon session, is geology and mineral resources continue. We have, there's an echo, sorry. We have our chairperson, Mr. Shamri bin Ramli, Director Planning and Management, Department of Mineral and Geoscience, Malaysia. Yes, and also co-chairperson, Dr. Tawachai Chualawanit, Senior Geologist, Royal Department of Mineral Resources, Thailand. Yeah, welcome, and I'll give the floor over to our chairpersons. Thank you very much.
Okay. Thank you, Dr. Diti. Thank you, the Secretariat. Hi and good day, good afternoon, good morning to everyone. Welcome back to our afternoon session, our CCOP thematic session. Today, I will chair this afternoon session with our co-chairperson from Department of Mineral Resources, Senior Geologist, Dr. Tawachai Cholawanik. So today we have 14 papers. For the first session, we have 8 papers. Then after coffee break, we have 6 papers. So for all the audience, you are welcome to post your question through Zoom chat or through your YouTube or by live. So we start with the first paper in the title of Geotourism in Stagadan Cave, the engine of the sustainable development for local communities in Satun UNESCO Global Geopark. In this paper will be presented by Mr. Raj Tiratna and Narogrit Tungpyu, but I be informed this paper will be presented by Mr. Raj. Now, please welcome virtually Mr. Raj. Please.
Hello.
You've got 50 minutes. Okay, you got 50 minutes for your presentation. Okay.
Can you hear me?
Can.
Okay. So I will start.
Yeah, you got 50 minutes. Then 10 minutes we will remind you. Okay, for your presentation.
Okay.
So please share your slides.
Okay.
Yeah. Can you slideshow?
Sure. Just a minute. Okay.
Okay. Good. Okay. Please.
Good. Good afternoon, everyone. I am Mr. Rajiratana from the Mineral Resources. Now I will present you on the topic of geotourism in Secondary Cave, the engine of sustainable development for the local community in UNESCO Global Geopark. This is my outline. First, I will talk about the location and characteristic of the cave, and after that, share the definition of geotourism, and followed by the geotourism in Secondary Cave, geotel, and followed by the how to support geotourism and challenge. Okay, sorry, I will start with the definition of geotourism. New sum and drawing keep the define that at the 2010 that the geotourism is focus on the nature area tourism and focus on the geology and landscape, and also is a promote geoscience and conservation of the geodiversity and understanding on the earth side, and application and learn and achieve to the independent visit geological feature, geotel and viewpoint. Yeah, in 2010, the geotourism look like the scientific tourism. It's not about know the community, but in 2013, the geotourism is the new something, and during the same researcher change the definition of the geotourism to sustainable tourism. Okay, with the focus on the experience on Earth, geological feature, and also culture and environmental affairs, and also conservation and joy, and joy with the people community, more involved with your community, and promote and protection, and who work with the geotourism have to talk with the different people, too much people involved with this process. And also, geotourism also is the engine to dive the geopark as well. I think the target of geotourism is the same as target of geopark. It's been a sustainable development to improve and increase the economy of the local economy. Let me show about the location of Secondary Cave. Secondary Cave is the northernmost, located in the northernmost of the Satoon UNESCO Global Geopark, in the Thungwa district area, 10 kilometers from Satoon Geopark Center. So if you want to come to the Secondary Cave, you will take the pickup or take the car around 10 minutes. You can start from the information center first, and after that, there are some staff explain you about what is geopark and where is the geosite around the geopark center, and the Secondary is really close, easy to go. This is the shape of the cave. The cave have two entrances and one exit. It's a very long cave in the southern part of Thailand. The cave is long around 3.39 kilometers, and you have to kayaking or along the route. Use around 3 hours to travel inside, and after that, after you exit the cave, you will see the mangrove forest, and enjoy with the biodiversity outside. The cave already mapping by Department of Mineral Resources in 2016. This is the cave feature that we found. It's very beautiful, and In the cave, we also found the mammal fossil as well. This is the cave feature. Yeah, in 2008, the villager found the Pleistocene fossil, and it's already defined to be the stegodon, the mammal fossil. And so why the name of the cave is the stegodon cave. The map shows the point that we found the path of the mammal fossil. There are 236 parts of the mammal fossil found in this cave, and 55 parts have defined already to be the mammal teeth. Some parts is the parts of the rhino. This is the biodiversity inside the cave. We found a spider and new species of the crab, and also the fossil or Paleozoic fossil as well. And it's the culture in the Tung Hua district. They are commercial with the Penang Island in around 100 years ago, and you can see the villager, like a fishery villager, and Chinese culture in this area. But most of people here is Muslim people, but they are still live together and enjoy together with the different culture. It is the state of this area. Okay, let me talk about the geotourism activity in Stegodon Cave Geoterror. With my idea, I use the model of Sujeri, the Korean geopark expert. He talked in the ecotourism and in the conference IBD 2019 about the geotourism. That geotourism have to link together not only at the first geotourism focus only the geological feature, but now it's already changed. We have to link between the geology, biology, and culture. Abiotic. Abiotic is mean geology. B is biotic, and C is the culture. And we have to link together and make some explain it and link and make some story about the area or the story of the geotale. Okay, I show some the resource of this area. We have the beautiful cave and mammal fossil, something we can talk about the process, and we can talk about a process of geology to build the area. It's very special because of the very long cave, and also we can find the Bangkok forest after exits. And we have the list of biodiversity inside the cave and outside the cave as well. This means because of the spatial geology here, and we can talk this one to the story to the tourists. And also the city have a very long history of the commercial between Thai and Malaysia, and so this is because of this list of the biology, this list of biodiversity, because of the geology is the reason. And why the culture is too many culture here, and it is I join together or the geology and bio and the culture to make the geotail. By the geotail first start from Geopark Information Center. And
Dr. Rat, you got another 5 minutes.
Okay, and go to the Stegodon Cave and go to the mangrove forest and back to the village. And this is very important that Stegodon Cave have to run by the community enterprise. He will protect the geo-heritage site. What is the enterprise that involved with the Stegodon Cave is not only the kayaking, maybe like culture, it involved with culture and local food, something. Everything involved and connect with the geology. If how to support, we have to, this is the idea that we have to support the geotourism. First, we have to support the geotourism material. Like it's very hard to talk about the geology to the community, to the local people. So DMR make the handbook for the geo guide to explain the people and build the information center in the front of the cave. And also education, we have to educate the local people to understand how to use the cave, what is the value of the cave, and how to protect it and how to use it and empower to local people. As I talked to you, the local people have to run this activity, and so you have to empower to the local and give the opportunity. Like we have to promote to the website and maybe to the website and Facebook, and maybe have some ceremony, special ceremony to promote to the people come to travel in this area. Okay, this is the related organization that involved with this geotail. And this is the income and number. This is the number visitor that you can see it light up until 2019. This is the number of the people and income in with this geotail to the community, directly to the community. You can see after use the idea concept of geotourism. This is my conclusion. I think it's very hard to talk to explain about geology to the local people. So interpreter and coordinator have very important to contact and transfer such information to the local community. And local community should be participate in activity from start and indicate. We have to indicate the development plan together. And effective workshop should be provided to the local community, and use assessment certification of the service. Okay, my presentation is already finished. Thank you. Welcome to the hotel.
Thank you very much for the nice and excellent presentation and sharing with us very interesting findings from Mr. Rats. So any question from the audience? Good. So any questions from the audience?
Yes, there is one question from Dr. Panya Chowsidi, please.
Please.
Yeah, you mentioned that DMR map the cave, and you show us the map. Unfortunately, there is no legend in the map. Can you a little bit describe more about this if you have just a pure limestone or something like that. And what I would like to mention here is not related to your talk, but what I'm afraid is the you mentioned about sticodon, but is there any source material which supposed to be a kind of place that you can believe whether sticodon? I think that is transported sticodon, right?
Yeah, I think so. It's transported. I think because of now the Ratchapat Nakhon University studying about this. But I think it's like a transport from outside. Maybe I think so.
But but how it how we can see it right in the cave, and what kind of transported things can it come from by seawater, or is derived from, I don't know. Is there any opinion on this? Because some people may believe, just like what I think, that if it is transported, then you need to find a source. I think it's a very important geological issue. That's my comment.
Thank you.
Okay, so we continue in the for the second presentation is from the Dr. Apisa Palestina on the topic early Paleozoic height and ultra high pressure complex of the West Central Asian orogenic belt, a review of the latest petrological and geochronological and isotopic studies. So before Dr. Apisa start, let me introduce in brief. Dr. Apisa is from a PhD in Geological Institute, Russia Academy of Science, specialty on the regional geology. So the floor is yours, Dr. Apisa.
Yes, hello.
Please.
Yes,
hello.
I'm going to, so can you see my presentation?
Can.
Yes.
Can you share slide?
One second. Yeah, the slideshow. Okay. So everything is fine? Okay, good. Okay. So, yes, my talk is concerns more fundamental questions, but I'm going to give this talk quite briefly and probably somehow introduce you to the observations of fundamental regional geoscience in the western part of the Central Asian orogenic belt, and also probably to introduce to some collaborations if our colleagues from Asia have some similar tasks, first in the fundamental geosciences. So I'm going to talk about the high and ultra high pressure complexes of early Paleozoic ages. It is based on our recent research, our recent article that we made with my colleagues. So the Central Asian orogenic belt is one of the largest fault structure in the world that is framed by the East European Siberian cratons, and also in the south it's North China craton and Tarim cratons. The Central Asian orogenic belt has evolved during the Neoproterozoic to Mesozoic, and has undergone by different cycles of evolution, and at the same time a number of large Precambrian terrains have, and which are composed of metamorphic complexes, have preserved within this really large structure. So I'm going to talk about the western segment of the Central Asian Organic Belt, which includes Kazakhstan, Kyrgyzstan, and northwestern part of China. So within this area, these are the Precambrian terrains, which also compose the metamorphic complexes which were formed in high pressure and ultra high pressure conditions. The most probably famous is in the northern Kazakhstan is Kokchetov Massif, which has the diamond-bearing complexes. And also, these are known from the southern Kazakhstan and northern Tian Shan. These are the Zheltao terrain, Turkendaktas terrain, also Issyk-Kul terrain, and finally the Ishim-Nari terrain. So very briefly, yeah, what does it mean? In the Kokchetov Massif in northern Kazakhstan, these are several types of amazing high pressure and ultra high pressure complexes. In the western segment, these are the diamond bearing complexes, which were formed at more than 30 kilobar. It means that the rocks were formed at about more than 100 at the depth, more than 100 kilometer. And in the eastern part, these are high pressure complexes, metamorphic complexes, which were formed about 20 kilobar. So, and you can easily see that how these rocks look like. So, and also the diamond-bearing complexes were investigated by the scientists from Russian Federation as well, and in collaboration with Japanese colleagues in the University of Ehime, and also these are several colleagues from Tokyo University and other in Japan and also from China. So the terrains in the southern part of Kazakhstan and northern Tian Shan also comprise from metamorphic complexes of early Paleozoic age, which also do not contain diamonds, but they contain the high pressure phase as coesite. It's the mineral of high pressure origin. And in the southern Kazakhstan, these are only high pressure complexes of early Paleozoic ages, which contains the main markers of high pressure region are the eclogites. Eclogites are special rock type of the high pressure metamorphic region. So what does it mean for the geologists? It means when studying the metamorphic high pressure and ultra high pressure complexes, we can argue that the rocks were formed by subducting of the continental crust to the great depth, more than 50 kilometers, while consuming the oceanic crust. And after the slab break off at different certain depth, yeah, the complexes were exhumed to the mid-crustal levels, and now they represent the tectonic slide packages, which comprise of the metamorphic rocks of the different high pressure or ultra high pressure region. These are, for example, the schists with garnet, kyanite, diamond, coesite, also eclogites, also garnet and spinel peridotites, and other rock types. So, and this is our summarizing time scale, from which you can see that in the western part of the Central Asian Organic Belt, the high pressure metamorphism mostly occurred in from 450 to 550 million years. And you could also easily see the that this metamorphism becomes younger, the age becomes younger, yeah? And the earliest stage is occurred in the northern part of this segment of Central Asian Organic Belt, and then moved to the southern part. So this is very, very brief observation, and if you need to know more, because it was very large observation, very large review, it will be my pleasure to share it somehow and to answer the questions. So thank you very much.
Thank you very much, Dr. Hafiza. So any questions? Because now Dr. Hafiza shared with us very interesting topics on the fundamental technology, which means I like the question, what it means to the geologists? This is the very good questions. So any question from the floor?
Mr. Zamri.
Yes.
Hello. Yes.
Hello, yes. Continue.
Yes. My name is Hamli. Hamli from JMG Malaysia.
Okay.
Okay, I want to ask about the green belt of the that topic you talked about. So this area could be a house for the gemstone deposit. So what kind of gemstone found it?
You mean what kind of deposits do we have associated with these metamorphic complexes?
Yeah. Because from the picture I saw like garnet mineral, quite big.
Yes. Of course, in the most cases, the metamorphic complexes, we can use it first, for micro diamonds, which are really good, of quite good quality, but it's a really rare case, But mostly, yes, of course, the garnets and also some other gems, could be used for exploration,
Thank you very much.
Yeah, Chair, so I have a short question. Rinya from Mahidol University. I like to ask, what processes brought the high pressure and ultra high pressure material up to the surface?
Oh, well, of course, it's a kind of fundamental question as well. But in the most cases, of course, you know that these are the rock types of different densities. For example, the crustal rocks have one dense, and the eclogite has another density. And it's a really large question. How do these rocks, with the different densities, could exhume together, And now the most popular answer is that this is the buoyancy river uplift, which is related to the slab break-off, and the rollback of this complex of the high pressure rocks to the surface.
Okay, thank you.
So any questions from the floors? Virtual floors. Any questions? So if no more questions, once again, thank you very much to Dr. Hafiza for your very interesting topics to us. Once again, let's give a big hand to Dr. Hafiza. Thank you very much. So now we move to the third papers on the overview of the basement rock in central of Thailand. This paper will be presented by Mr. Sitanong Kutashois from the DMR. So please, Mr. Sitanong, the floor is yours. You got 50 minutes, 10 minutes, we remind you. Okay, please.
Your mic is still mute.
Oh, still, man. Oh, okay. Can you hear me?
Can. Continue.
Okay. Good evening, good afternoon, everyone. My name is Sinon Kuntaksayot from Department of Mineral Resources, Thailand. So today I like to talk about the overview of basement rock in the central of Thailand, which this project is still going on. So now I'm still in the field work. This this project, I have another two co-worker, which is Miss Chonipa Fak Sengsa and Mr. San Asawapachala. So let's start from the first slide. I like to start with about the study area. So in the central Thailand, the basement rock is covered about 5 provinces, which show on the map on the left side of the slide. You will see the boundary of the pink one, which is the boundary of the Precambrian rock, which connected with other lower Paleozoic rock from the Cambrian and Ordovician rock. So the orientation of the basement rock from the north is on the northeast southwest direction, and southward in the lower part is mostly north south direction. So my study area is covered in 5 provinces, which is Tak province on the north, from the north southward to Kamphaeng Phet, and then Nakhon Sawan, and then Uthai Thani and Kanchanaburi province. So the basement rock is mean the high metamorphosed rock mostly are nice cheese, and also is contained with the calcilicate, marble, and cheese. So the relationship between the basement rock and the lower Paleozoic rock from the previous study said that it had the contact by unconformity or the faulting contact. So from the north in Tak area, we have a metamorphic complex which called Lansang Night Complex. So the mostly of this area from the bottom, it has the dark colored fine grain gneiss with high contents of biotite integrated with another organ gneiss and quartzo-feldspathic gneiss with intercalate with marbled lanes. So it's overlain by the slightly less metamorphosed rock such as quartz mica schist, tin-bedded or quartzite and quartzite, and then it has overlined by the lower Paleozoic rock by unconformity or fall, which we have no clear evidence in the field. So from the picture, you will see the nice picture from Tak Method District Highway, about 64 to 72 the kilometers. So we see the interbedded between the light colored, like white colored, and the dark colored, and also it has small of the folding inside of the bed. So it's a little bit high of metamorphose, like ductile and brittle, because it's along the big fault zone, like mapping fault. So the sequence of gneiss in the Lansang gneiss complex can be divided into 3 units, the different. So I divided into unit A, unit B, and unit C. So unit A is the quartz feldspathic gneiss. So the color is a little bit white. And then the another unit B is organ gneiss, is the gray gneiss with the porphyrobust of the feldspar inside. And the unit C is melanitic gneiss with the higher contents of the biotite. So the 3 units is intercalculated. So I called all of them is nice. And then this nice underlaid by the quartzo-feldspathic crosser grain, and it had the marble intercalate inside and covered on the top by the quartz mica sheet with the pictured, the lower pictured. So the quartz mica sheet intact, it showed the thin bedded. So another interested study area is in the Bhumipol Dam in also in Tak province. So this basement rock sequence in the Bhumipol Dam contained with the microcline biotite gneiss, overlaid by marble and calcilicate rock with mineral assemblage, for example, mineral assemblage plagioclase biotite, epidote amphibore, and slightly have tremolite diopside, garnet, and some and other opaque minerals. And then on the top is covered by mega sheets. So this picture show on the left, it show the calcilicate rock at the Bhumipol Dam, and from the first location about 100 about 1 kilometer is the mega sheet on the left picture. In Kamphaeng Phet area, we have Klong Khung gneiss, which has 5 different lithologies of the rock. I can divide into 5 units. So the first is auto gneiss with coarse-grained granuloblastic texture, and unit 2 is gneiss porphyroblastic texture. Unit 3 is calcilicate with granuloblastic textures as well, and unit 4 is quartz epigonula texture, and then the last unit is unit 5 is the granite. So this relationship is the gneiss is put it the lowest of the column and then overlined with calcilicate and then covered by the quartz and gneiss. So this area and Lansang area very similar, but in Kamphaeng Phet area we'll find more folding than the Lansang gneiss. So the picture I show on this slide, it's showing the quartz mega sheets near the Khong Lan waterfall and the calcilicate rock near the Khong Nam Lai waterfall. And the last study area in Kanchanaburi, the geology map, this one I made it after Nantasin. He studied the gneiss in 2013. So he divided the basement rock sequence in this area to 4 units. From the unit A is marble and schist, unit B is mylonite, unit C, the gray color is calcilicate, and unit D in the purple is gneiss. So I show the study area of the quartz mega sheet at studied position number 44, and number 40 is marble and calcilicate. So this is the result of the petrology studied. So showing the phyllobass of all gneiss in the central Thailand. So the phyllobass is contains mostly the feldspar, and some of them is had the microcline, and also some are quartz and garnet. And calcilicate at the Bhumipol Dam Tak contain mostly diopside and zoisite and also amphibole as well, compared to the calcilicate that soured the Tak at Kamphaeng Phet province. It also have diopside and tremolite. So the composition is very similar.
Dear Sitana, Mr. Sitana, you got another 5 minutes.
Oh, thank you. Okay, and then the geochemistry data on the major oxide, I can plot and group all gneiss and schist from the study area. They are grouped in the pelitic rock, which they may become metamorphosed from the a little bit fine grain sedimentary rock with high content of quartz or clay mineral, and also can plot it in the log in the lower diagram. It shows that it can group it in the greywack, which like poorly sort grain sediment rock with the rock fragment and feldspar. And also I put another nice sample in the normative feldspar diagram, and it shows that it can group into group with its granite and adamelite. And the composition of them are mostly the calc alkaline. So the conclusion of this study, so the basement rock or infrared Precambrian rock in the central of Thailand are interbedded between the fine grain gneiss and a little bit closer grain by porphyroblastic gneiss, which overlain by quartzo-feldspathic gneiss with marble lanes and calcilicate, and is covered by quartz schist and mica schist on the top. So the relationship between basement rock and lower Paleozoic rock is still no clear evidence to prove that there is unconformity or fault contact. So the strength of shear from the feldspar as the pyloblast on outcrop, showing the sinistral direction, and also under the microscope also show the sinistral direction as well. The geochemical position of gneiss and schist show that they can group in the pelitic rock, and mostly composition are alkaline. So the suggestion is the age of basement rock is still debating. So the uranium lead age data view can support the recrystallization age and also the metamorphosis age, which will confirm the age of basement rock in Thailand and can use it for compared to other basement rock age in Southeast Asia. And I done. Thank you so much for your attention.
Thank you very much for your nice and excellent presentations, Mr. Stino. So any question from the floor? I think maybe question from the Thais, because it's talk about the overview of the basement rock in central of Thailand. Please, any questions?
Yes, Mr. Chairman, I have one question to ask. From your slide or the photo that you show us, it seems like for the gneiss unit is seen to be paranise. In the area that you study, you have by any chance to found the exposure of some other gneiss in those areas?
Yeah, I can find some, but I didn't show on the slide. So the alternate is a little bit going into the core of the area. Like if we think about the map I show the first slide, so my sampling area is still a little bit outside than from the core. But if going inside more in the core, we'll see the alternate and also some granite inside as well.
Thank you.
Yeah, Mr. Chairman, I have a short question.
Okay.
Kun Sitinon, you
Yes,
have give a very interesting talk, and you have any comments about the ages report by our Austrian isotope geologist about the Lansang gneiss? They have the age ranging from perhaps from Triassic to around 20 or 30 million years old. You have any comment on that ages?
Yeah, mostly of the dating age of Precambrian rock in Thailand is in about Mesozoic age. So very slightly have like older age. So mostly they assume that age to be the metamorphism age. So we still cannot assure the lichistorai age because probably I think my idea, so all of the basement rock in Thailand probably they remelt again because of area is contained with we call it migmatite. So probably that occurred by is because of its remelt again and cannot
Okay.
calcify, which is
I
rock.
think, but you can continue after this.
Oh, okay.
So
So
we thank you very much, Dr. Mr. Sintinong. So once
thank you
again,
so much.
give a big hand to Mr. Sintinong for the excellent and very nice presentation.
Thank you so much.
So now we move to last paper for the geology is UNFC, a tool for securing sustainable and affordable energy, raw materials and resources-based service during the coming reforms to meet the United Nations Sustainable Development Goals. This presentation will be presented by Mr. Pearl Blister from Petron. So, Mr. Pearl, this floor is yours.
Thank you. Thank you very much, Mr. Chairman. Can you hear me and can you see my presentation?
Can.
Thank you. Thank you for the opportunity to present to you some important news regarding the United Nations Framework Classification for Resources. This is not about geology, but it's about management of the geological resources. So allow me first to draw your attention to the natural resources trend in the world. Last year, the United Nations Environmental Programme, UNEP, released a Global Resources Outlook Report 2019. And some important messages are there to be taken home. They have compared the material footprint in tons per capita and looking at the development from 1970 until 2017, almost 50 years of difference. And you will see that the difference is striking. There's been an increase in the material footprint for all income classes except for the low income, but you see the upper middle income and the high income is growing very much. And this indicating there has been a significant increase in standard of living for a growing population. Let's just see about the numbers behind this graph. We see that the population has grown from 3.7 billion people in 1970 up to 7.6 billion people in 2017. So it's doubled. However, the annual global extraction of materials has grown from 27 to 92 billion tons. That's a threefold increase. And at the same time, the average material footprint has grown from 7 tons per capita to 12 tons per capita. It's obvious that if this is going to continue, we will need at least 7 planet Earth by 2050 to support this growth. So this is the continuation of this trend is not sustainable at all. Now, if we look at the historical trend here, we see that mineral resources have been decisive for well-being and development. And each new technological epoch has been characterized by the availability of new mineral resources for use, which in turn have led to new technological developments. By advanced mining and refinement technologies, almost all useful elements on the periodic table is available to us today here. And we see the development going from the windmills of the 17th century here up to the modern windmills and solar panel, and we have to utilize a lot of mineral resources of different kinds. We know that we need to have a strong reduction in emissions of greenhouse gases, and a large proportion of that is coming from combustion of fossil fuels. And development and utilization of low emission energy is necessary. And both windmills and solar panel are examples of technologies that are important there. And all this is challenging our way to manage the resources. We need a lot of resources to do this in the coming years, but we cannot afford to overuse or waste our restricted resources. So this is a picture showing the UN Sustainable Development Goals, just to remind us here. And we see that the rapid increase and sustainable utilization of natural resources and the global temperature rise and climate changes that we experience is calling for sustainable resource management and mitigation of climate change adverse effect. The UN Sustainable Development Goals, which were adopted by the World Nations in 2015, is well known to us. In fact, the CCOP new strategic plan is based on the SDGs, so it's a very promising development. But we also know that production and deployment of all forms of energy and resources have environmental consequences. Many of them will be enhanced by the negative impact of the climate change. And we need to develop and implement strong, common, sustainable resource management system. And here, United Nations Framework Classification, UNFC, can help us. The UNFC, in the middle here, is developed as an international project-based resource classification system and is based on environmental, socio-economic viability, and technical feasibility of projects, reflecting the confidence in estimates of their metrics. And it's currently designed to be used for renewables, energy, petroleum, coal, minerals, underground storage of CO2, and anthropogenic resources, and water is coming on. This makes UNFC an excellent tool for classifying and intuitively organizing interrelated information about resources on projects, resource specific, as well as trans-commodity inventories at all scales, from individual project to regional portfolios. The fundamental characteristics of UNFC, which is a resource project-based system, comes as an important key to unlock and open the boxes of the UNFC, which you see here, all these colored boxes. Because the project carries not only information about the volume or amount of the resource being produced by the project, but it also carries all other information related to this project as development, implementation, operation, and even cessation of the project. So operational cost, investment cost, labor, tariffs, emissions, and waste, they are examples of this type of information. So I want to talk about the United Nations Resource Management System, UNRMS, which is actually an extension of the UNFC. UNFC provides a snapshot of the metrics in time, but the UNRMS is a dynamic tool. And it will support analysis and be a tool to assess alternative actions to secure affordable and sustainable energy and raw materials services that we need. The expert group or resource management, EGRM, which may be known to some of you, is charged to develop, maintain, and promote a comprehensive United Nations resource management system. And that means that they will be using the UNFC framework to further develop principles, specification, guidelines, application protocol, best practices, we need that, and case studies, very important case studies to support sustainable management of energy and new minerals and raw minerals. And metrics for the projects and asset holder, including the governments, will be the core of the system. So by reflecting the stocks and flows in both physical and monetary terms, it will be become possible to assess contribution to sustainable development and temperature rise of investment portfolios to audit the assessment. This is important because UNFC can be an important tool in supporting the development and application of international sustainability reporting standards. There are now studies by many key organizations, including the International Financial Reporting Standards Foundation and the Financial Stability Board, whose members have more than $100 trillion under management. It is an amazing amount of money. Then the investment houses, they are focused on sustainability and impact on temperature that the investment will cause. They may wish to assess the risk for the investment, both with a view to contribute to the future that we want, respecting their obligation to secure continued returns to avoid investment in assets that become stranded before the money can be returned to them. So there are three main drivers in the development of the UN RMS. Of course, we have the government and international organizations like the UN. They are defining and implementing the framework conditions. These must be designed to allow industry to deploy their best capabilities dynamically to create the physical reforms that are required. Then the industry, they are deploying their capabilities, which is their competence and capacity within the framework.
Mr. Perk, you're going to end up by 5 minutes.
Yeah, thank you.
Okay.
Then provided that the activities can be funded. As we know, a company does not have money, only debt that belongs to lenders and equity that belongs to the shareholders. Then the capital market is financing the industrial activities, but only to the extent that this allows it to meet its proper obligations. So all these three main elements are important. Government holds the key, but not the industrial capacity, nor the funds required for the very major change that is required to meet the SDGs and the climate obligations. Only the capital market does. So this brings me to the conclusion. We see that the large and growing population is coming out of poverty. And we see that also the current growth of natural resource use is not sustainable, and it calls for development and implementation of sustainable resource management system. The energy system must be reformed to secure affordable energy services while meeting the climate restrictions. And raw materials are imperative. Massive amounts of diverse raw material services are required to do this. There's an urgent need for policy frameworks that allow the industry to deploy their best capabilities to reach the goals in ways that the capital market can finance to reach the conflicting goals. The UNFC is designed to help all these three by being project-based, and they're classifying projects with respect to environmental, social, and economic criteria, technical feasibility, and degree of confidence in the estimate of the metrics. So by extending the UNFC by the UN RMS, that will help analysis of policy instruments considered for reaching these goals. We see that international cooperation is required for normative instruments like the UNFC and for setting necessary global constraints. Then the UN and other international bodies and the International Financing Reporting Standards Foundation in particular are needed to create strong and efficient sustainable resource management where international instruments are required for the gears to be engaged. Then lastly, we know that each country is unique and have different starting points and conditions to respect when choosing the pathway to sustainable development. So it's important not to copy others, but to listen and learn and find the best solution. So this concludes my presentation. You can find more information about the UNFC at the UNECE homepage. The link is provided here, or you can contact me through the email or by telephone. And thank you very much for your attention. Thank you.
Thank you very much, Mr. Paul, for your excellent presentation and very informative. So I like the statement, the very important statement: sustainable development and climate change mitigation cannot be achieved without energy and raw materials. With that, any question from the floor? Any question from the floor? Any question from the floor?
Okay, Chairman.
Yeah, okay, continue.
Actually, that just a question, but I would like to some comments. And first of all, thank you very much for very nice presentation. And all in the morning, so he even joined our opening ceremony. It was quite amazing. So too early in the morning. So actually, UNFC is the really very decent program to think about the social responsibility to the environment. So we have to follow. And then CCOP is also have a very straightforward plan to follow and promote that program, and also try to having some international center of excellence in the near future, and then try to find some funding for that kind of issues. So actually, your contribution, and then Mr. Publistat is giving us many good presentations and workshops and education for the CCOP member countries. We really appreciate that opportunity by using this this occasion. Then, so at the moment, exactly how many countries is applying UNFC methodology, or maybe UNRMS, to their the resource assessment of their own resources? That do you have that kind of number, or how many countries? Because many countries has their own resource classification methodology, which is of course a little bit different framework. Thank you.
Thank you for your question, and it's an important question. I'm afraid I don't have the number of countries which is actively using the UNFC. There are some countries now which are using it for the mineral resources classification, but the uptake of UNFC is growing, and what we see is that UNFC actually is an umbrella classification. So you can map your own classification into the UNFC, and you can then have a common platform for communication. So it will be, I think, when the UNRMS, which is under development and will be developed, it will be a very strong tool for nations to utilize when it comes to resource management. So I think in the coming years we will see a very steep uptake of this classification system and the resource management system and ideas behind it. But the numbers I can't give you, unfortunately. Thank you.
Thank you. Thank you very much, Mr. First. Share with us, very informative, and we learned a lot from your presentation. Once again, thank you very much. Let's give a big hand to Mr. Per. Now we move to next paper from the Republic of China on the title of Behavior and Fate of Geogenic Uranium at Basin and Site Scale in Shallow Groundwater Systems. So please, Mr. Yawu from Republic of China, the floor is yours.
Hello, can you hear me?
Can. Please.
Okay, thank you.
Please, can you share your slide? Okay, make it a slideshow, please. Okay, nice.
Ladies and gentlemen, good afternoon. This is Wu Yao from the Wuhan Center, China Geological Survey. I am very happy here to give a talk about behavior and fate of geogenic uranium at basin and site scales and shallow groundwater systems. It's a case study performed in the Datong Basin, northern China. Uranium is well known for its weapon use. However, human uptake uranium where food and drinking water may cause chlorine health effect because of its chemical toxicity and radioactivities. Therefore, WHO proposed guideline values for your concentrations in drinking water at 30 microgram per liter, while U is not listed in the drinking water standards in many countries. Since groundwater is the primary drinking water source in many parts of the world, due to anthropogenic activities and natural processes, elevated U concentrations in groundwater potentially threat to public health. Groundwater with contaminated with geogenic uranium are reported in Datong of Shanxi province and the Hetao Basin in Mongolian China, while the 300 area situated along the Columbia River is frequently reported as with your deposit site. Uraninite, coffeenite, and barbarite are the most common texture-valent uranium minerals and are sparingly soluble. Hexavalent U minerals is often adsorbed onto and incorporated into carbonates, oxides, phosphates, various elements, silicates, sulfate, and vanidates. Oxygen, ferric iron, nitride, and magnesium 4 can chemically oxidize uranium 4. Sulfide, ferrous iron, and sulfate can reduce uranium 6. Nitrate-dependent uranium oxidizing bacteria, metal oxidizing bacteria can microbially oxides uranium 4. Ferric iron and sulfate-reducing bacteria can reduce uranium 6 by transferring electron from organic matter to uranium 6, obtaining energy for growth. Uranium ion and its complex with bicarbonate, phosphate, calcium are highly soluble under near neutral to alkaline conditions. Ferric iron and sulfate reduction periods are the discharge areas of regional groundwater systems in sedimentary basins. Hence, which make risk of mobilization of nature ignored in these areas. However, favorable geochemical conditions may cause oxidation, complexation, desorption, and further mobilization of yield. Therefore, the objective of this study is to unveil behavior and fate in the shallow quaternary aquifer systems. The study area Datong Basin is located in North Shanxi Province, northern China. It is under a semi-arid climatic region. A geometamorphic complex outcrop to the east and north, while for the west and south. Cambrian to Permian sandstones, moss stones, and shells outcrop. regional groundwater flows from the mountain front area to the central basin. We collected 117 groundwater samples throughout the basin and 33 sediment cone samples from the DY side. At the XGT site, the central basin, we constructed a multi-aquifer monitoring site at the south bank of the Sangam River. It contains 20 well nets, 3 PVC pipes pumping groundwater for 3 aquifers in each well. Since there is a reservoir downwelling upstream, which drains water to downstreams only at irrigation time. Middle April and late October, as a result, the river here is almost dried up at most of time and only experience high river stage at the irrigation period. With about 1 week, groundwater flows from the river and upstream to the center. River water intrusion to the aquifers is obviously observed. Hydrogen and oxygen isotopic composition in the rainwater show seasonal variations and linear regression. Namely, the local meteoric waterline. This suggests the groundwater has many hydrometeoric region. The main elements loadings and the pH values display spatial variations in general high yield concentrations. 10 to 209 microgram per liter occur in the south flow-through areas and shallow aquifers of the distal areas. Extremely high yield concentrations occur in the depths 3 to 20 meters below land surface. For the site, yield concentrations disagree along the flow path. The main elements loadings and the pH and EH values display seasonal variations. Higher yield concentration is accompanied by higher calcium concentrations. Sediment yield sequential extraction suggests residual U and U bound to carbonate are the main yield host. And the XRT patterns specified is always identified in the select samples, while bannerite is only identified in 1 sample. Betified, a hexavalent U mirror typically from granite and pegmatite. Same AGS analysis show yield appears to be on iron-bearing minerals in the secondary iron hydroxide, calcite, dolomite, and tibicite. According to earlier oxidation experiment, less than 1% of uranium-4 could be oxidized during our sequential extraction procedures. Therefore, beta-5 and the combined bound U are the main hosts of U, and their reagent will release uranium-6. Geochemical modeling shows that uranium calcium carbonate complex are the predominant U space in groundwater. The correlation suggests that higher pH and bicarbonate concentrations contribute to formation of the anionic species, while higher calcium concentration favors formation of the neutral one. And desorption of uranium ions is complex from the ferrihydrite contributed to enrichment of uranium in groundwater. Same EDS analysis of the black grain in the sediment indicate biogenic maculoide, which is also supported by the similar vertical variation of contents of total reduced in organic sulfur and the total organic carbon. Also, geochemical modeling results show that siderite and maculoide respectively dominate under modest and strong reducing conditions. These two favors are highly reductive to uranium-6. Because dissolved oxygen and nitrite preferentially react with maculoide and biomass, direct oxidation of crystalline uranium by DO and nitride is hindered. However, favors R can be oxidized by oxygen, nitrite, and the indigenous manganese. For the resulting ferrous R solutions, ferric R solutions have ferric hydride is the initial hydrolysis product. They may occur as nanoparticles. Therefore, it's able to contact and oxidize uranium 4. For surface water groundwater mixing, on the one hand, it brings oxide species into the aquifers, leading to oxidation of ferrous R and the formation of ferric R. The former ferric hydride oxides uranium 4. In addition, silicate stability field and strong isotope binary mixing model suggests silicate weighting caused by surface water groundwater mixing, which also release uranium. Overall, beta-5 and the combined resin and the uranium-6 desorption from ferric hydride are the primary geochemical process responsible for mobilization, with minor contribution for uranium-4 oxidation. Orbitic redox process may be mainly related to dissolved oxygen, amorphous ferric hydride, molecularite, and siderite. Higher bicarbonate concentrations and lower calcium bicarbonate ratios result in formation of the allylic space and uranium-6 desorption. With increase in calcium concentrations and calcium bicarbonate ratios, this allylic space may shift to the neutral one, favoring uranium-6 further desorption.
Mr. Yahoo, you got another 5 minutes. Oh,
thank you very much.
So thank you very much, Mr. Yahoo, for your very informative and excellent presentations. Any questions from the floor? Any questions?
Yeah, yes.
Okay.
Can
Continue.
I ask a question?
Okay.
From
please.
your study, which natural induced or human induced contamination is more important?
Mr. Yahoo, one question, which are human induced or
natural
induced
or human induced contamination is more important from your
Mr. Yahoo, one question.
I'm here.
Okay.
Sorry, I can't quite follow you. Please repeat your question, please.
Okay.
Okay, I have another short one.
Okay.
What source of damage, the health damage caused by the uranium contamination, the major damage?
Damage.
Mr. Yahoo, what is damage from the uranium contaminations? So I think better, Dr. Priya, can you use a chat, Zoom chat? Later on, Mr. Wu will reply. Okay.
Oh, okay, I do that later. Thank you.
Okay. Okay. So any question? So if not, once again, thank you very much for Mr. Yahoo for your excellent and very nice presentations.
Okay, thank you.
So now we move to next presentations on the mineral exploration using unmanned aerial vehicle case study in Korea. I think this is a very interesting topics. This presentation will be presented by Bona Kim from Korea. So the floor is yours, Bona Kim.
Welcome, everyone.
Okay, can you share your... Okay, continue, please continue.
Okay, my name is Bona Kim from Korea Institute of Geoscience and Mineral Resources. Today, I'm going to introduce about our research, mineral exploration using unmanned area vehicle case studies in Korea. This is contents of my presentation. First, I want to briefly talk about what we do and what do I want to talk. And then I will simply explain about the unmanned area vehicle systems. After that, I'd like to show examples about mineral exploration with UAV. Okay, I'm working at Korea Institute of Geoscience and Mineral Resources. We call it KIGAM for short. KIGAM is the unique government-funded geoscience research organization where the top-notch R&D are ongoing. So this slide shows the organizations of KIGAM, and among them, I'm working at the Mineral Resource Development Research Center in Mineral Research Divisions. So this figure shows the concept of our research. The final goal of our research is to figure out where and how much mineral exists. For this, we gather many geological and geophysical data, such as geochemistry map, airborne magnetic anomaly map, and geological map, drilling data, and so on. After that, we construct 3D geological model, mainly based on geological map and drilling data. After block modeling, or data are transferred to 3D GIS data with proper interpretations. And then based on 3D model, various GIS queries create useful data for mineral targeting. After that, after data integration using geostatistical method, we could get the 3D mineral potential map looks like this. So among these processes, today I would like to introduce the mineral exploration systems and examples in KIGAM using the unmanned area vehicles. Of course, some of you already know a lot about UAVs, but I would like to briefly explain the advantage of UAVs and UAVs classifications. Unmanned area vehicle is basically any aircraft flying in the sky without a pilot, where it be flying autonomously or with a remote control on the ground. As you probably noticed, they are becoming increasingly common as technology rapidly advances. Then why people focus on the UAVs? This slide shows the advantage of UAV. So first, it is efficient than conventional method. It is cheaper to operate and fast to run. Second, it is less dangerous to operate. Next, there are various sizes and shapes, so depending on the purpose, we can choose the proper types. And lastly, precise flight with computer control is possible. Because of these advantages, they can be used complementarily with conventional area methods. There are currently no official main categorization for the different types of UAVs. So we have classified drones into 4 main categories: fixed wings, in single loader, and multi-loader, and unmanned airships. And this slide shows the main advantage and disadvantage of each types of UAVs. Okay. So in this presentations, I will introduce an example using unmanned airship and multi-loader UAV, considering the presentation time. So first is about airships. We developed a manned area system for magnetic survey based on airship. This system consists of magnetic sensors and balloons and gondola with embedded system for autopilots and data acquisitions and communication modules and ground control stations. The airship was fabricated from non-magnetic fiber reinforced plastic and urethane cloth and filled with helium. So the maximum payload is 10 kilograms and flight time is approximately 1 hour. So this movie shows the examples of iron ore deposit detection using the developed unmanned airship. The unmanned area vehicle shown in this video is an early version. So we inject the helium gas in the balloons, and after takeoff manually, we change the mode to autopilot. The airship is flying through the assigned GPS waypoint. Looks like this. And through the emergence of acquired data, the distributions of mineral was successfully predicted. Okay, next, the other examples. We also applied our developed system to explore high-quality limestone. In this area, magnetic survey using the developed unmanned airship was conducted 4 times to obtain data from area of interest. And then using the magnetic data acquired from unmanned airship explorations, we performed the inversion and we could successfully obtain the 3D susceptibility model, looks like this. And from the result, we could identify the igneous body which can be source of minerals. Last examples. Recently, we also applied our developed system to perform the magnetiferous titanomagnetite explorations. Okay, the unmanned area vehicle shown in the video is the latest version. A camera is mounted on the underside of the unmanned area vehicle, so you can check all the flight scenes. And an automatic flight algorithm enables stable and efficient explorations, and a radio frequency modem and LT router connect the airship to ground control even when it is not in the line of sight. And through the emergence of acquired data, the distributions of mineral was successfully predicted. Looks like this. Okay, next I would like to introduce exploration example using multi-copter systems. In KIGAM, various studies using multi-copter systems are underway and can be classified into 3 main categories. First, airborne geophysics systems. Second, remote sensing systems. Third, photogrammetry for generating precise texture terrain models. So in this presentation, I explain only airborne geophysics and some kind of examples of our photogrammetry for the sake of time. And this slide shows the magnetic survey system. For this survey, magnetic sensor called Mega Arrow was used, and this sensor is developed by Geometrics. This slide shows the aeromagnetic survey result using helicopters and multi-copter in the same area. Through these 2 figures, we can clearly see that we can get more sophisticated data using multi-copter than using conventional manned airborne survey method. In addition, using multi-copter system, we can repeatedly obtain data by varying the height for the same path. Okay, using the acquired aeromagnetic data, we could identify area having high potential, and we could verify the locations of high quality ore body through drilling. We are also developing radiometric survey systems as shown in this figure. We try to use the right weight radiometric sensor. This movie shows the test flight. We tested the performance of equipment by placing a radioactive source in the center of exploration area. And this image shows the test. This image shows the test results. We can see that the radioactive source is accurately detected. And we are developing electromagnetic survey system based on multi-copter. And this is the EM equipment, and source receiver interval is fixed, and investigation depth is less than 10 meters. And this equipment is currently in the verification stage, and the system can be used for environmental problems and detections of buried objects. Lastly, I want to show you about the research of photogrammetry. This is because digital elevation model can be importantly used to accurately interpret the obtained geophysical data. So this slide shows the simple process of 3D area photogrammetry for 3D geological modeling. So first,
Kim, you got another 5 minutes.
Okay, thank
5
you.
minutes.
Okay, first take a picture of area. We want to make a 3D geological model using the multicopters. Second, make sure that the picture taken overlap well. Then using the data, we can generate the digital elevation model, and 3D geological model looks like this. Lastly, we prepared a video to give you an example. It is not directly related with the mineral exploration, but it will be a good example about photogrammetry. So this video shows the results of photogrammetry study using a drone to observe changes in the island of Dokdo in South Korea. Okay. Yeah, what you see now is the actual island. We took a picture with multicopter systems. This is the result of photogrammetry. This is the DM model we got. We could delineate well, even though the island has very complicated topography. That's all my presentation. Thank you for attending.
Thank you, Bonakim, for your interesting topics. You share with us tools for the future for the exploration. So, any questions from the floor? Very interesting topics. Any questions? One questions.
Yes.
Okay.
What is the depth? Hello.
Okay, continue.
What is the depth that the radar can penetrate in the flat area?
Thank you for your questions. The depth of investigation is different depending on the sensor. The magnetic sensor is about, it can be about 100 meters, 100 to 300 meters. It's really deep, but in case the EM sensor is really short, so it can only detect the 10 meter or 10 meter depth. Yeah, so it, depending on the sensor, it will be different.
Okay. Thank you once again. Thank you, Bonakim, for your interesting topics. So once again, let's give a big hand to Bonakim.
Thank you.
Now we move to the next paper from Malaysia. It's from Dr. Jasmine. He's a senior lecturer from the University of Malaya on the topic of the rare earth elements potential in selected area along the Central Bank in Peninsular Malaysia. Please, Dr. Jasmine, the floor is yours.
Okay, thank you very much, Mr. Zambri, our chairman, and thank you very much for everybody. So I will share now my screen. Okay. Okay, can everybody see the things?
Please, no.
No.
Please share your screen.
Yeah, already sharing now.
Yes.
Everybody can see it?
Tapi sangat.
Can please share your slide.
Yes, I'm sharing it now.
But we can see.
Yes. Wait.
Dia punya tu besar apa?
Okay. I'm sharing now.
Yes, we can see your presentation now.
You can see already?
Please continue, Dr. Jasmine.
Okay, all right. Okay,
But
so
we cannot see your face.
Okay, but can you see my slide?
Yes, you can see the slide, but your face is black.
Okay, all right. I think it's okay. We can just see the slide. Okay.
Okay. Please continue.
Right. Okay, so the paper is entitled "The Rare Earth Elements Potentials in Selected Areas Along the Central Belt in Peninsular Malaysia." So this slightly a very fundamental and very preliminary paper.
Kita tolak tadi 2 minit.
Okay, so it's actually a collaboration with my university, University of Malaya, the University of Science of Malaysia with my friends Zakaria, and also my colleagues, Professor Azman, and the 2 agencies or 2 industries that involved in terms of the research is the SMGB Group and the CNMC Gold Mine Holdings Limited that produce some fundings to our students to carry on the research. Okay, so why actually we are doing this? Okay, for us, the rare earth elements such as the lanthanum, the ceriums, the neodymium, and also europiums are very valuable. Okay, most of the things it could be goes up to even thousands of ringgit Malaysia's per ton, and it could be used in terms of like in the optic, the automotive catalysts, the rechargeable batteries, even the supermagnet. So we see that is the high demands for the advance in the technology nowadays and in the future. And just for information, the rare earth elements can be classified to light rare earth, the LREE, and also the heavy rare earth elements as what we call HREE. So we also see that the studies of the rare earth elements in Malaysia has not been extensive enough fundamentally and practically. So we are very determined to carry on this research, and we are looking into the potentials of rare earth elements along the central belt of Peninsular Malaysia, and 3 locations that we are carry out our research is at Pergau and Kuala Kerai in Kelantan, is more or less at the to the north and the center part of Malaysia, and also Benter, slightly in Pahang. Okay, so this the pictures of the Kerai area or Kuala Kerai. So you can see the things in terms of the is more or less a combinations of granites and cyanide in some places in Benter. And what we are focusing is into the fresh rocks that we can manage to find in the areas, and also the weathered material. So we are focusing in both setup, the weathered materials and also the existing fresh materials. So here we can see the Kerai materials with granite, and there are some weathered materials also coming from the granites. This one is the very nice outcrop that we managed to found in Kerai. Okay, it's likely a very good boundaries between the fresh and the weathered material. Okay, Pergau also same. We are targeting both soil and rocks materials, and Benter is more with soil materials that are weathered from shynite and granite materials. Okay, so this more or less the horizons that we managed to found in that particular area. Okay, so in terms of geological background in that particular area, Benter is more or less situated in the Benter formations, and then some scholar predict and explain it as due to mantle plume processes, but this one is slightly open to debate and discussions, and it's a poor-orogenic processes and does not associate with the oceanic crust subductions in terms of in the period of latest Permian-Triassic collisions. Okay, and the Benter complex mostly sosonitics and occurs furthest away from the trench and found closely to the Bentong Raup suture line. And one scholar, Muhammad Rozi, indicate that Bentong area near the Jeram Besu are rich in quartz diorite, porphyry, shynite, and also monzonite. And the Pergau, it could be dominated by gonatoid body based on the Northern granites and the Kenrong liquor granites. And they are in the field observation, there are 5 variations of granites there. Coarse grain granites, very dominant with quartz and feldspar, the fine grain material, the pink megacrystal biotite granites, and the coarse grain dominant with hornblende and foliated granite. And in the Kuala Karai area, it's covered by the formation of Gomusang and Takushis, and it's likely very highly correlated with the granite stone complex in the western part of the Kuala Karai. So this is more or less a general geology of the 3 areas that we visit and carry out the field work. Okay, so because the advancements of nowadays we are looking into the rare earth elements, so so this one of the things that we do for now is to find the potential. So in terms of the Benter area, this is we are using all the lanthanide series, lanthanum to lithiums, and also we include the scandium and also yttrium as a like a benchmarks materials also lah. We clump it together into a 17 elements. Okay, so we segregated the samples from soils and rocks. Okay, so you can see here the BSB is the soil and the HR are the rocks itself, the fresh rocks. So we can see here the total RE for the Benter area. Some of the samples of the rocks materials exceeds 500, and there are some with total rare earth elements together with scandium and yttrium achieve 800 ppm. Okay, so for us and from the benchmarking that we do from previous paper and existing mine in the world, is slightly enriched with materials that anything above 500 ppm. So even the hard rock itself carries about 400 ppm of total rare earth, and the CE anomaly and the EU anomalies corresponds to the more or less with the ion exhaustion clay materials. Okay, and the lanthanum and the yttrium ratios indicate that the light rare earth elements are slightly more compared to the heavy rare earth elements. Okay, so basically here I will show you after this the spider diagram. So in terms of the Pergau area, we also do the same things. We segregate soil and rocks, okay, based on the horizon. So here some of the soil samples, okay, it's also exceeds 500 ppm, our benchmark of the research. But there are some also, they are quite low in terms of 200s. There are some with 300 ppm. So this one is slightly less materials in terms of PPE concentration in terms of the rare earth elements. Okay, and Kuala Karai also same. We together with soil and rocks. Okay.
So Dr. Jasmi, you have another 5 minutes.
Okay, yeah, sure.
Okay.
And this one is another in terms of the Kuala Karai, they are slightly quite low materials lah. Okay, and here you can see the orange color is the rare earth elements. Okay, the total. Okay, the dull green is more or less with your light rare earth elements, and the heaviest one is slightly with the lighter green. So you can see for 3 areas that we visit and carry out the research for the potentials REE, Benter area is one of the most prolific, right? Because some of the material exceeds 600, and they are also achieve 800 ppm. Okay, and this one is all the spider diagram, so you can see it's already proven that the light rare earth elements are is higher compared to the heavy rare earth elements, so it's slightly there the results. Okay, and we also see some segregations in terms of the lanthanum and yttrium ratios. So the Benter area is slightly more towards higher materials, and is slightly more materials with the light rare earth elements. Okay, and we also, when we do the samplings in terms of in the B horizon of the soil that coming from the weathered granites or even the weathered shinites, so we can see some variation in terms of the depth, in terms of the part per millions of the rare earth elements. So this one is slightly, you can see here, some are slightly with the pattern. When you slightly going down, then you achieve, or when you reach the horizon B, you get more rare earth elements. But you can see also there are also variations with the here you can see the cerium of the Pergaud area is slightly more in just 1 meter of depth, and slightly depleted a little bit and going up again when you goes about 2 meter of depth. Okay, so we continue with all the things with depth, and also with cry also is here we put it as a distance from the ground. So you can see some materials with the cerium should be in a very good horizons of about 2 to 2.5 meters from depth of that particular areas, and your lanthanum also is good with the 2 to 2.5 meters. But here you can see the europium is slightly more with 1 meter from the ground. Okay, so this one is all what we do to in terms of the to strategize where the next explorations and the next potential horizon of the material can be carried out. And also we also more or less put some of the chemical index of weatherings to see is it the weathering effect of the granites also takes response in terms of the high concentrations and high compositions of the rare earth elements. Okay, so for us as our preliminary studies, so we can just conclude that the ratios of the light rare earth elements compared to the heavy rare earth elements for Pergaud, Benter and Kolakrai are between 30, 60 at the Pergaud, and 6 to 37 in Benter, and 14 very little ratios here in terms of the Kolakrai. Okay, and our understanding also the rare earth elements are coming from the REE bearing monazite and xenotime. It could be also with the allanite and also ilmenite and rutiles. And the total REE concentration is high in Pergaud and Benter. Okay, but Benter one could be about 500 to 800 ppm, and the Pergaud could be about 400 to 580. Okay, so the potential of rare earth elements along the central belt is very encouraging for us in terms of these 3 locations. And however, the detailed study on the mining aspects such as its economic value, the viabilities, in terms of the resource and reserve, and in terms of the techniques itself, in terms of either it could be done with the ion adsorption clay methods, either it cannot be done. So that one is still under our research, and what is the future works that we hoping to carry out in the future. So for that, I conclude and I open the floor for any comments or any questions.
Thank you very much, Dr. Jasmine.
Yes.
Due to the time constraint, if you the audience got any question, you can post to the Zoom chat or by YouTube. Then Dr. Jasmine will reply. So
Yeah, sure.
Once again, thank you very much, Dr. Jasmine, for your
Okay.
interesting topic share with us. Let's give a big hand to Dr. Jasmine.
Okay, thank you very much.
So now we move to the last paper for the first session is on the from Malaysia also from Fakhruddin Hafid from Fakhruddin Hafid is from our JMG Department of Mineral Geoscience, our branch in northern parts. He will talk on the thorium, rare earths, yttrium and scandium potential from placer deposit, a reconnaissance study on monazite and xenotime from the Jerai Pluton Kedah, Malaysia. Please, the floor is yours, Hafid. Please continue.
Hello and good afternoon to all. Can everybody hear my voice?
Can. Please share your slide.
Okay, I'm sharing my slide. 1 minute. Can you guys see my slide?
Not yet.
Not yet?
Yes.
I think there is problem with my sharing. Can the secretariat play my slide, please?
Secretariat, please assist Hafid. You got the slide, backup slide.
I have problem sharing my slide.
So, Marabit, can you please assist Hafid from the backup slide?
Let me try one again. One second.
Please. Dr. Tawachai, can you assist from the secretariat? Okay. Now we can see.
All right. Thank you very much.
Please continue.
Okay, greetings and good afternoon to all. My name is Fakhruddin Afif Fauzi from the Department of Mineral and Geoscience Malaysia. And I will be presenting thorium, rare earth elements, yttrium and scandium potential from placer deposits, with sampling from a reconnaissance study of monazite and xenotime of Jerai Pluton in Kedah, Malaysia.
Sweat.
Okay. So in this thematic session, I am also representing the Malaysia National Chapter of Youth Scientists, which is also known as YES Network. So this is the outline of my presentation. Okay, next. So recently, rare earth elements, thorium, yttrium, and scandium demands are increasing. Developed countries like the US and China are acquiring these elements as many as possible for inventing high-tech gadgets and devices, energy generators, supermagnets, as well as other industries, for other industries. So as shown in the slide is the periodic table of the elements, highlighting the position of the rare earth elements in the lanthanide series. Scandium and yttrium are having the same group, group 3, sorry. And lastly, thorium being lonely in the actinide series at the bottom. Alas, yttrium and scandium are commonly regarded as REE because they naturally exist together. Next. So this graphic shows some of the use of REE in today's technology, such as magnets, metal alloys, like phosphorus, catalysts, ceramics, and glass. Next. This graphic shows the use of thorium as thorium oxide, being the better minerals to be used as energy generator, as THO2 does not easily oxidize and resistant to ionic radiation compared to uranium minerals. Next. The discovery of REE is dated back in 1788 when Johann Gadolin found an uncommon black rock in Ytterby, Sweden. Many European scientists tried not just to define what are the elements in the black rock since the finding, but they were competing each other to discover the elements in the lanthanide series in order to complete the periodic table of elements. Next. So let us get back to Asian region. In Malaysia, monazite was the main byproduct of tin mining from nearly a century ago. Early study of this phosphate mineral in Malaysia have been done by Splinter and Wan Fuad. In dry area, they characterize the monazite as green colored, with elongated roll grains of flattened form or well-rounded at some or all parts. Monazite from other areas in Malaysia are generally clear to deep canary yellow to cream colored due to progressive oxidation of REE. About 7,000 tons of monazite have been produced in Malaysia from year 2000 to 2010. And the thorium content in Malaysian monazite ranges from 2,525 and ppm up to 41,000 ppm. Next. This microphoto shows the unique green and shape of Jerai monazite during this study, which is similar to Wan Fuad and Splinter's descriptions. So as we can see here, the size is very small, up to micron scale. So next. Xenotime is also a phosphate mineral and also one of the main byproducts of tin mining in Malaysia. Wan Fuad differentiated the xenotime as having squat tetragonal bipyramid in Malaysia's western tin belt, including the Jerai area, and having prism with double pyramidal termination in along Malaysia's eastern tin belt. And xenotime also commonly found intergrowth with zircon. Next. So this microphoto shows the shape of xenotime from Jerai area during the study, the middle there. The color is green to pinkish color. Next. These tables briefly show the production, these tables show some of the minerals containing thorium and REE. As mentioned earlier, this study only focuses on monazite and xenotime as they are highly resistant to weathering and relatively abundant as placer deposits, because other minerals are not highly resistant, so cannot appear in placer deposits. Okay, next. So the study on monazite and xenotime in Malaysia and their occurrences are parts of regional mapping or geochemical survey by Geological Survey of Malaysia since 1925. The study on radioactive mineral, including thorium, has been done in year 1993 to 1995, focusing on the central belt of Peninsular Malaysia, as shown on the map. Next, JMG started the reconnaissance study on REE in 2018. Previous slide, please. The initial study also focused on the REE, including thorium contents in placer deposits, and one of the selected study areas is Jerai Kedah. So next slide. So this table briefly shows the production of monazite and xenotime in Malaysia from 2009 to to 2018. And these rare earth minerals are obtained from among retreatment. Next. So regarding the study area, the Jerai Peak consists of Cambrian Jerai Formation intruded by the Triassic Pluton, which is known as Jerai granite. The granite are characterized as having three phases, which are biotite muscovite. The study area comprised of a part of granite, also comprised alluvial plains covered with paddy fields, and source of water come from streams flowing the Jerai Peak. Next. So this is the geological setting of the Jerai area. So the Jerai consists of Jerai granite, which is Triassic, including the quasitic to schistic Jerai formation, which is in Cambrian age. And the granite is having three phases, which are biotite muscovite granite, tourmaline granite, and pegmatite. Next slide. So the map generally shows the granitic intrusions in Peninsular Malaysia. So the Jerai area is put to have aged around 210 to 210 to 220 million years and regarded as part of the main range granite in Peninsular Malaysia. Next. This map shows the general geology of the study area. The pegmatite phases, as shown as picture at the top right, occurred as veins ranging from cm scales to several meters, cutting the two mica granite and quartzite.
Afif, you got another 5 minutes.
Okay. Next slide, please. So these are the methodology of the study. So we take the sample by panning, and then we remove the lighter quartz, and from the samples, we do the QME analysis and LAICPMS to obtain the concentration of the thorium, REE, and scandium, as well as uranium. Next. So these are the location of the sampling location. Okay, next. So these are the origins of the concentrate samples, which we took from gravelly layers, weather bedrocks, alluvial sand deposits, and stream beds. Next. This photo shows the weathered outcrops, which granite and pegmatite, and from this outcrop, we also took the concentrate samples. Next. So this is how we dug the pit holes, and from the pit holes, we differentiate the distinguishable layer, and we took the samples from each layers. Next. So this is the magnetic separator in our lab in Ipoh. They look old, but they're still useful. Okay, next. So these are minerals according to magnetism from our guides okay, as we can see here, monazite and xenethime, it appears in fraction of 0.7 ampere and 1 ampere. Next. So the results and discussions. Garnets and tourmalines are the most common minerals found in all study areas. Sampling location, and monazite and xenethime contents from streambed samples are higher compared to other origins in recent fluvial environments, and their contents are up to around 8% and 6% respectively. And monazite and xenethime contents in weathered pegmatites are higher compared to weathered granites. Lastly, the monazite and xenethime contents are also higher in the western part of the alluvial plain, which is up to 3% and to nearly 3% in both monazite and xenethime, but lower than samples from recent fluvial environment. Next. So these tables show the monazite xenotime, and all other minerals that we can see under the microscope. Next. So these are the minerals that we see under the microscope. As we can see, garnet, monazite, xenotime, and tourmaline. Next. So in the quaternary plains, the eastern part are dominated by sand, but the western plain are dominated by clay and mud. Next. So these tables show the result of monazite, xenotime, and all other minerals from the pit holes. Next. So these are the samples from the pit holes. We can see tourmaline a lot and some of monazite and garnet in the samples. Next. So the star shows where the high content of monazite and xenotime are taken. Next. So according to LAICP MS results, the thorium, rare earth element, and yttrium contents are very high, which respectively up to 1,500 ppm, 21,000 ppm, and 7,600 ppm in samples containing monazite and or xenotime. However, scandium content is very low in all samples, only up to 87 ppm. But scandium shows positive correlation with monazite and or xenotime contents. Next, this table shows the result of thorium, uranium, scandium, and REE, as well as yttrium in all selected samples.
Please wrap up your presentation.
Okay, so can we jump to conclusion, please? So the conclusion is the monazite and xenotime content in dry area is respectively up to 8 to 6% in current stream beds, and both rare earth minerals are originated mostly from pegmatite compared to barite granites, and their content low of previous marine sedimentation or sea level rise or flooding from Greater Merbok River further south. And REE, thorium, yttrium, and scandium content follows the content of monazite and xenotime. However, mining of these minerals are not very likely to be economic in dry area. However, this study provides indicators for possibly higher contents of REE as ion absorbed in clays and environmentally mineable via solution mining. So we'll recommendation of SRD analysis and place and testing clay horizons on the weathered granites. Okay, that's all from me. Thank you very much.
Thank you, Mr. Afiq, for your nice and very excellent presentation. However, due to the time constraint, I saw one question from the chat from Mr. Teo Lai Hock. I hope Mr. Afiq can reply the questions due to the time constraint. So once again, let's give a big hand to Mr. Afiq for the nice and excellent presentation.
Thank you very much.
Now we up to the end of the first session presentation for this afternoon. Now I'm hand over to the secretariat. Please.
Thank you very much, Mr. Samri, Director Samri, for your excellent chairperson of the session for the afternoon. Now we are a little bit late, 10 minutes, which is not so bad. Thank you very much. Yeah. Now we have coffee break, and also we will be showing the video clip from poster sessions. So if anyone would like to have coffee or tea or break, you can bring your coffee and tea, and then you can also watch a video. So I'd like to hand over to 3:30 sharp. Yeah, we only got 20 minutes the most. Yeah, hopefully we can play
all the video clips. If not, then you may possibly see it from the website, or you can check the poster on our website as well. All right, then we'll see you at 3:30. Thank you very much.
Thank you, Damni. Thank you.
Mic test, hello.
Yeah, I heard you.
Was replaced to enhance the property and geoscience department. We go through to the introduction of the poster. Definition of crystal glass is contain 10% of metal oxide, is highly priced compared to the other glass type due to the quality of its raw material. Basically, small impurities such as iron could affect the crystal glass color, hence the purity sense. Silica oxide is commonly used to overcome this drawback. Okay, traditionally, silica traditionally crystal glass were produced from local silica sand. In this research, silica rock was replaced to enhance the properties of silica. Several methods were suggested in the literature, including the use of ultrasound for surface cleaning of silica and acid leaching and reverse flotation techniques. Okay, in this research current work, crystal glass from local silica rock was prepared via psychochemical method using low concentration organic acid. Attraction scrubbing in a figure 3 was used to conduct with citric acid as the chelating agent. Citric acid is more lower cost than sulfuric, hydrochloric, nitric and so on. Citric acid also is a natural acid with low molecular weight. It's considered a non-persistent biodegradable product with a half-life in a soil suspension of close to 8 days. Okay, this characteristic make citric acid a sole and potential medium for the effective recovery of silica oxide even at low concentration. Okay, the methodology of this research divide into the field investigation and sample collection and experimental work. Figure 1 show the silica rock deposit of study located in Lojinggo, Musang, Kelantan. Okay, the potential silica rock deposit cover an area of about 34.96 hectares. Okay, the silica rock sample were characterized with light grayish color and coarse grain surface in a figure 2. Okay, we further the research with the experimental work using assembled impeller system, which is we use extraction scrubber at the constant parameter as mentioned in the poster, which is we use acid concentration of less than 1% and constant scrubbing time and speed of agitation of 20 minutes and 1250 rotation per minute respectively. Okay, we go through to the result and discussion. That one is a phase identification using XRD analysis. Figure 4 show the XRD pattern of the silica rock sample. It show the crystallized silica rock intense peak at 2 theta, 20.86 and 26.64 degree indicate the presence of crystalline silica. Okay, the phase of silica rock is a tetragonal silica phase. We study about the composition of the silica rock, the chemical composition of the silica rock in table 2. Later I will show you the table 2 reveal high and consistent percentage of silica oxide of an average value of over 98.12 weight per mass. The silica rock was characterized with low percentage of alumina and magnesium oxide. Minor of peroxide, nitric oxide, calcium and titanium were also present at low percentage of not exceeding 0.6%. The average loss of emission value was 0.3%. Okay, 3.3 show iteration scrubbing of the silica rock sample. There are many factors affect the color of the silica rock, including silica oxide contents. After we treat using 0.75 the recovery of silica is increased from 98.75 to 99.87, and the other element ferrum oxide is also decreased from 0.40 to 0.114 after using citric acid. Okay, we go to the refractive index, density, Vickers hardness of different crystal glass. In general, the refractive index of the crystal glass from the silica rock was higher than 1.50, thus fulfilling the specification for crystal glass application in accordance to the British standard. Table 4 also indicate the density values were in the range of the fully crystal and crystal glass with at least 10% of beryl oxide, plumber oxide, and calcium contents, either individually or group. Okay, table 4 also indicate the hardness of the crystal glass produced from East Coast Malaysian silica rock was lower, within the range of 414.2 kg for centimeter square to 486.03 km centimeter square, compared with the value stipulated by British standard. Okay, in conclusion, the silica rock is very suitable and more soft than silica sand properties. So it's a very suitable for crystal glass application.
Hello, good afternoon again. I hope everybody is okay, ready for the last session for today. I'd like to hand over the floor to our chairperson, Dr. Tawachai, please.
Thank you, MC. Good afternoon, all participants, both online and in the meeting room. So we'll come back to the second half of the session. In this part, there will be 6 papers await for us. So, and one paper will come from the Malaysian, 3 papers from Myanmar, and the last 2 from Thailand. So let's begin with the first one on iron oxide and zinc oxide doped 8YSZ for a sustainable fuel cell technology, a comparative study on of thermal analysis, historian structure, microstructure, and conductivity characterization. So this paper will be given by Dr. Tisha Selvaraj from the Mineral Research Center of the Department of Mineral and Geoscience JMG. So the floor is your Dr. Tisha. Are you ready?
Yeah, I'm ready. I share my screen, okay?
Yes, please.
All right. Okay. Can you see my screen?
Yes.
All right. Yes, button? Okay,
Go
I
ahead,
Go
promise.
please.
ahead.
Okay.
Very clear.
A very good evening to everyone. I'm Dr. Tinesha from Mineral Research Center, Department of Mineral and Geoscience, Malaysia. Okay, these are my co-workers, Dr. Ismail and Associate Professional Banjuraiza Johar from University Malaysia Perlis, and Dr. Kaw Sing Pang from University Malaysia Perlis too. Okay, I'm going to share my research on this, but this is not fully minerals. Okay, it's about iron oxide and zinc oxide, which is doped with 8 mole% of yttria stabilized zirconia, which is used for the fuel cell technology. Okay, before going further, let's see what is the problem they're facing in our Earth nowadays. Humanity top 10 problem for the next 50 years. Without a doubt, the biggest issue is energy. In 21st century nowadays, which energy is the main supply for all the electricity and transport for goods or person are the basic of modern life. We as a human being, we are using energy every day and everywhere. Do you agree with me? I'm sure. Okay, so that as the population is increasing about 1.2 to 2% per year, about 12 billion in 2050. So it will lead to a lot of problem where we tend to humans build power plant to burn all the fossil fuel, where the burning creates steam to rotate the turbine to create the electricity. But there are few drawbacks from here. First is global warming, but the carbon dioxide are. Next is the pollution, ozone depletion, and global surface temperature eventually will increase about 0.6 degrees Celsius per century. Okay, we know that the renewable electricity, we only use about 26.5. So where my inventor is come in, where a fuel cell to generate the electron, to produce a clean and chemical process of hydrogen gases and oxygen gases to produce a completely clean and renewable cycle, which is zero pollution. Okay, here come with a fuel cell. Fuel cell is in the middle part. They have negative anode and positive cathode. The middle part is the solid electrolyte. The main purpose to have a dense electrolyte for the properties. The second must have a high ionic conductivity. It's difficult to achieve this high ionic conductivity because there are few parameters will affect on the ionic conductivity. For example, the particle size, sintering parameter, degree of compaction, dopants, and trace elements as well. Therefore, 8 mole% of yttria stabilized zirconia, where the yttria is come from the REE, where there are a lot of types they have used for high purified, about 99% like Japan, they're using of Toxo, Switzerland, ceramic, pecan, this one, Daiichi. But can you imagine that the price already very increasing when we buy the commercial one? Can you imagine that when we complete the research, it really costs a lot of money. So therefore, it can produce a low yield and not practical for a large volume of product. Therefore, I'm using this, try to use a much more cheaper and the waste material for this 8 mole% of yttria stabilized zirconia. This 8YXZ have a multi-model of diameter sizes and have a high amount of trace elements as shown in the below. And this material is eventually can cut off and save about 85% with the previous commercialized product. Okay, so I will play with these dopants, iron and zinc. Okay, iron was chosen because it tends to reduce the sintering temperature, increase the grain size, and shift grain size with 3 mole%. We have to use less than 3 mole%. More than 3 mole, it tends to decrease in the ionic conductivity. Whereas the zinc, it will form a smaller grain to close the pore and enhance the grain size as well. The second one is enhance the densification and control the grain size. So here, where I come in, I will use these two dopants in order to improve the densification and ionic conductivity. Okay, there are a lot of parameters I have go through. This is among the best. The single dope, which is sample of 2 mole% of iron, and the zinc is 2 mole% of zinc. which is sample G is about 1.75 mole percent of iron, 0.25% of zinc. Sample Y is 2 mole percent of iron and 1 mole percent of zinc. Okay, let's see the result. Okay, this is the result of the activation energy by dilatometer and the densification we calculate through the wet and the dry sample as well. Okay, activation energy for 2 mole percent has the highest value. We know that the iron has a smaller size, which is 0.78 Armstrong, compared with the ZR, zirconia, and yttria ion as well. Zinc dopants has a lower sintering activation energy compared with the pure HYSZ, because it tends to incorporate the zinc into the zirconia lattice, which can enhance the densification of the zinc as well. Where when we're using the dual dopants, zinc and iron, eventually can act as a lubricant, reduce the friction, and increase the hopping rate. As the sintering temperature when doing the sintering process, the porosity of the green compact is declined, and the particle face with the greatest resistance in the mobility and can improve the densification about 90% for each and every one. Okay, so this is the first main point that I say that densification must more than 90%. Okay, now we come for the XRD analysis. So we I calculate the quantitative by using the XRD. I come up with the cubic phase and the tetragonal phase. Okay, cubic zirconia, which is stable in the high temperature, will transform to the tetragonal transformation upon the cooling down due to the presence of stabilizer, which is a dopant in the case of this zirconia. So cubic phase normally is provide a better mobility of the anion, and the contraction of the lattice parameter is dominant by the oxygen vacancy in the lattice, because cubic is all A equal to B equal to C. The lattice is much more asymmetry compared to the tetragonal. Tetragonal phase, low tetragonal, which can enhance the ionic conductivity because we want more in cubic phases. Okay, eventually higher cubic phase can lead to higher oxygen vacancy because they are aligned or orderly, so they have a high chances of oxygen vacancy, which eventually can influence the ionic conductivity behavior. So the last one, lattice parameter. The lower the lattice parameter, it can less the distortion as well. Okay, now we go for the crystallized size. Okay, crystallized size for iron enhance the grain growth rapidly. The zinc able to control the rate. So as you can see the morphology, the zinc, the grain growth is started to grow very faster compared to the zinc. The zinc is control the growth rate. That's why I mix them together. It eventually can control both of them. So when mixed dopant is able to produce the optimum grain size, small crystallized size tend to increase the ionic conductivity, where the previous researcher also has stated that smaller crystallized size will reduce the low grain and grain boundary resistance and promote the mobility of ion and vacancy oxygen that contribute to the higher ionic conductivity. So this is the iron, which is have a zinc. Zinc have a lower, can control the grain growth. Okay, then we go for the last part is the tetragonality and the total conductivity. Okay, highest crystalline distortion is to the A and C because we calculate the tetragonal C over A, and the phenomena is known as a crystal lattice distortion. Higher lattice distortion, which can eventually drop down the ionic conductivity. So mixed dopant of G has achieved the highest total conductivity in current study among the best. Okay, so when I compare my result with the previous studies, so yes, the black color is the current study, the blue color is the previous study. So it shows that yes, it's improving by using the dual dopants as well. So the ionic conductivity in current study show the best is compared with the previous study. Okay, the summary is the novel composition is the dual dope that I'm using in the fuel cell application, and the sample G has obtained a good result, optimal result compared with the rest. Okay, there are some recommendations. Why I'm doing this is I will try this to same method, I will try to fully using the minerals in Malaysia. And the conductivity, the properties of mixed dopant, I only study on the low temperature. Maybe we recommend to use in the high temperature. So this is an essential point to consider the usage of the mixed dopant in this fuel cell. So the first one, we need to save the energy. The second one is just produce a zero pollution to our earth. Okay, that's all from me. Okay.
Thank you, Dr. Tanisha. Thank you for keeping a good time. Do anyone have any questions from the floor? We still have some time to for some questions for the Dr. Tanisha. Well, it seems like I doesn't have any questions for you. Maybe like if later on anyone have questions, please contact Dr. Tanisha
Yeah, sure.
personally. So thank you again, Dr. Tanisha, for your very interesting presentation. Please give a good hand for her.
Thank you.
And next, we move to the second one. It's going to be about the geology and occurrence and gemology of Kamti Amber from Sky region, Myanmar. This talk going to be sent by the Dr. Ted Chin Yong. So may I give his general background of his career a little bit. Dr. Ted Chin Yong used to be a professor from the Yangpu University, and he studied in gemology, mineralogy, and petrology. And currently, he is the Director General of the Department of Geological Survey of Myanmar. So now the floor is yours. Dr. Ted Chin Yong, please, and please share your presentation. Dr. Ted, can you hear me? Dr. Ted, please open your mic. We cannot hear you.
Good afternoon, all, and thanks, Mr. Chairman, and all participants from CCOP country. Today, I would like to present the geology, occurrence, and gemology of Candy Amber from Sakai region, Myanmar. In my presentation, there are 7 outlines in this end. Bamai or Myanmar amber is found at the Tanai region in Hukong Valley in Kachin State and also at the Thilen in Magui region. Moreover, another occurrence of amber is found in Patabon, also called Patabon, which is located near the Nampilin Stream, about 40 kilometers southeast of Kandy in Kandy Township, Sakai region. The present mining sites are Lechon Mo, Chap Mo, Shan Mo, Jam Mo, Chowtan Mo, and Nam Indra Mo. Mo means mine in Myanmar. These are the location map of Patabon amber mine. The other 2 amber mines are this one. The topmost is the Hukong Valley. This is the one of the mine site, and the other is the Thilen amber location here. In the Patabon area, the low-grade metamorphic rocks such as Campbell schist and similar schists or Nagar hills are exposed in the eastern part, which includes the Glucophane schist, graphite schist, Apido schist, etc. And Obidolena fossil-bearing limestone, which may probably be mid-Cretaceous Albian age, integrated with sandstone, shaly limestone, and carbonaceous limestone are exposed at the Patabon area. Other sedimentary units of Miocene age of Upper PQ groups are widely exposed in the western, middle, and northeastern part. These are the regional geological map of the Patabon area where the Patabon amber mine is located, the red area. Now I would like to express about the occurrence of amber. Amber is found in the Ovidolina fossil-bearing mid-Cretaceous Albian age limestone. The thickness is ranging from a few inches to 2 to 3 feet and integrated with sandstone and carbonaceous shaly limestone. And sometimes these limestone together with carbonaceous material. These are the evidence of fossil, the Ovidolina species, which are present in the amber-bearing limestone, and it can be tentatively set mid-Cretaceous Albian age. Now I want to express about the Patabon amber mining site. The top two are the Lechon Mall and the lower one is the Chao Tan Mall, where the ambers are mined. The 5 major production mine sites includes 13 blocks where the mining operation has been operated under the Season Star Company Limited. Now they are being mainly operated at the Lechon Mall, which is currently the most productive site, and other production sites are Chap Mall, Sham Mall, Ja Mall, Chao Tan Mall, and Nam Indra Mall. This Nam Indra Mall is now under suspension. These are the mining operation for the amber at the Lechon Mall. Now we can see the amber-bearing limestone and the extracted amber, and also amber in the limestone together with the some carbonaceous material, and also amber together with the black carbonaceous material in the limestone. Now the manager of the mine show the amber in the amber-bearing limestone, and he show also the extracted amber from the amber-bearing limestone, and these are the rock under the ambers are amber-bearing limestone, and these are the extracted amber from the mine site, and this also amber in the limestone. The mining activities of amber is carried out at the amber production site. The depth of the bedding of the amber-bearing limestone vary from 20 to 30 degrees, and the amber production is carried out along the bedding plane by the adit. The primary amber mining is carried out by blasting the amber-bearing limestone and sandstone and carbonaceous shaly limestone along their bedding plane and editing into the limestone for exploring the amber. The excavated amber-bearing limestone were sorted by manpower at the outside of the adit. These are the small adits which follow along the bedding plane of the amber-bearing limestone. That here we can see the approximate depth of the 20 to 35 degree of the bedding plane of the amber-bearing limestone. Here is also the mining operation at the Lechon Mall, where the adit is digging into the inner part of the amber-bearing limestone. These are the small adit where ambers are extracted, and the amber extraction are carried out by the can and explosive, and then they put it into this yellow bucket and to the surface by pulling the pulley. This figure shows the nature of amber in the amber-bearing limestone and shaly carbonaceous shaly material in the unit. The body gas shaft is sometimes used to extract for the amber, which is locally called leaping, and it's mean 4 into 4 square feet of the body gas shaft is operated to the amber-bearing rock and then digging the adit following the bedding plane of the rock to search for the amber. Also, open cut method is carried out at the Japmo, Shammo, and Jammo, where the overburden is covered on the amber-bearing rocks. These are the nature of the vertical shaft, and here we see the full square stoping vertical shaft, which is digging vertically, and then when they reach to the amber-bearing limestone bedding and follow along the bedding plane. This is also the same, and this wooden wheel is used to roll up the material inside the shaft to the surface. And these are also the vertical shaft along the amber-bearing unit. Now I would like to continue to explain the gemology of amber. The color of Patabon amber vary from yellow, greenish yellow, orangey yellow, golden yellow, brownish yellow, brown, and reddish brown, and rarely as red. They show the transparent to opaque, and the refractive index ranges from 1.53 to 1.54, and specific gravity is ranging from 1.03 to 1.09. The higher specific gravity, 1.09, is due to the attachment of calcite on the amber. The ultraviolet radiation always shows that very strong chalky yellowish blue and a long wave and weak chalky yellowish blue or greenish weak chalky yellowish blue or greenish and are the short wave. Some of the deep brownish material display weak chalky blue or yellow under the long wave ultraviolet light and inert under the short wave ultraviolet light. These are the 21 analyzed samples from the present study from the Patabon, and the size of the sample ranges from 0.45 to 2.9 carats. These are the color varieties of Patabon amber. Now I would like to continue to the inclusion that included in the amber. Inclusion that's contained in the present study are flattened gas bubble, flow marks, some brownish organic debris, and various insect inclusion. For example, spider, flies, and feather-like and plant-like inclusion, and some organic materials. These figures show the central part is the feather inclusion, and the top left side is also the feather inclusion in the amber from candy. These figures also show the some insect inclusion inside the candy amber. This one is the spider inclusion, and this is also the dragon, probably dragonflies. And these are the some ants inside the amber, and these are the some parts of the insect that I cannot identify, and these are the some mosquito-like insect inside the amber. These are the some plants debris, some plants and organic materials, and these are the flattened gas bubble, and this lower parts show, lower figure show the some parts of the insects. For the comparison with other ambers, the 11 sample show that they are quite similar to one another, and the higher features were dominated by a group of absorption bands at around the 2,800 to 3,000, relatively narrow band in the range of 950 to 1,750, overlying a broad hem at the 800 to 1,400, and a weak broad band at around the 3,420. The position of relative...
sorry, Dr. Ted, you have 5 minutes left.
Similar to those seen in the iospectra of the Myanmar amber reported by various authors. But Patabon amber did not show significant absorption in the 1050 to 1250 region, and additional band at 1764 was not detected. These are the iospectra amber from Thailand, and these are the iospectra from Thailand. Now I would like to compare and show the Raman analysis of the candy amber. The FTIR spectrum of amber show similar appearance of those of the Thiele and Tanai amber, similar like these above two figures. And no absorption band at 3048, 1642, and 887 of the Raman spectrum of the same sample, this one. These are not found in the Tanai and Thiele. This confirms that this is not a copper, and this asterisk is due to the absorption of the carbon in the air. Now I would like to go my presentation to discussion and conclusion. The gemological properties of candy amber, such as refractive index, specific gravity, and bright luminescence and long-wave ultraviolet illumination are quite similar to amber from the Thiele and Tanai region. But a difference consists of a broad OH stretching related IR absorption band around 3500, especially at 3400 in our sample, in the spectra of candy amber. This band is not found in amber from Thiele and Tanai, and it can be attributed to OH stretching. So just to clarify, Tanai and Thiele was carried with only 5 samples of each, and IR focus were on the 3000 low. So following the discovery of 3500 in candy amber, our co-author T. Dyson decided to do a preliminary analysis of the Tanai and Thiele sample around 3500 and found that some samples appear to have the same peak at 3500, which we need to do for the further analysis to confirm it. So considering the presence of carbonate group, this hydroxide can be assigned to the carboxylic acids rather than the molecular water in candy amber. So characteristic FTIR and Raman spectra of yam copper have not been observed from the Badabon amber, which provide the confirmation for the older age of the amber, that is, Middle Cretaceous, Albian age or older age, as confirmed by the Orbitolina species fossil in the host limestone. So it appears likely that candy amber was captured and buried earlier or during the formation of the Middle Cretaceous limestone. Thank you very much for your kind attention. And
Thank you so much for the Dr. Ted presentation, and thank you for bringing us into the amber world in Myanmar. So for the floor, do you have any questions? Yes, Dr. Prinya.
Very nice talk, very informative. Can we conclude that the amber was formed on land and being transported and redeposited in shallow marine?
I think this is not transported. This amber was probably formed in the host limestone during their formation, because the nature of the amber inside the limestone not look like the transported material.
Hello. Amber is very light, 1.43, 1.
Yeah,
1.9. So they are float. They almost half float, saltation, and
yes.
not transport like gravel, like sand.
Yes, not like a sand, but probably the material that will be formed as the amber was deposited during the regression period and buried with some mud-like or some shaly materials inside the host rock, and then they will be formed by the overlying sediments again, and then maybe formed by the pressure of the overlying sediments to be amber.
And another short question: what is the extensive of these Middle Cretaceous limestone?
Excuse me, I haven't.
What is the area covered by these Middle Cretaceous limestone? How large the area?
The extent, it is large, very large. The extent is nearly nearly half a mile. It's exposed a large area. Yes.
Okay, thank you.
Okay, thank you so much. Because of the time restriction, please forgive the big hands to Dr. Ted Chin Yong again for his very good presentation. Thank you so much. And next is going to be the presentation on gold mineralization at Payong Tong mine area, central Myanmar. This talk gonna give a present by Mr. Win Pio. Mr. Win Pio is a geologist working at the Department of Geological Survey and Exploration, the same department with Dr. Ted Chin Yong. He got his master's degree from Kyushu University, and his expertise is in geological mapping, mineral exploration, and also economic geology. So, Mr. Pio, now the floor is yours. Please share your presentation.
Okay, and now I have to share my presentation. Can you see my presentation slide?
Yes, could you make it in the mode of slideshow mode, please? Make it bigger. All right, good. Please continue.
Okay, thank you very much for the invitation to meet. Today, I'd like to talk about my research. The title is the gold mineralization at the Phaeon mine area, central Myanmar. So this is outline of my presentation. So firstly, I'd like to talk about the introductions and metallurgenicity of Myanmar, then the geological background. After that, methodology. The main topics of this presentation is the mineralization and the fluid inclusion microthermometry study. And final one is the discussion and conclusions. So now I'd like to talk about the location of my story, the areas, Phaeon gold mine area. So gold mine area is situated near the Mandalay city. So Mandalay city, the second biggest city of Myanmar, not so far from this city. So as you know, Yangon is the largest one of Myanmar. So the gold deposits area is situated about just 30 kilometers northeast of Mandalay city. And the geotectonically gold deposits, the occurs within this slate bed. Which is mainly composed of the metamorphosed sedimentary rock, and also sometimes some places we can offset some igneous intrusive rock. And the western part of the area, which is bounded by the Mogul's metamorphic bed. So there are two combinations of this beds. So now the recent research work, the names and Mogul's and Mandalay Margui bed. This beds mainly hosted both significant intense mineralization, also associated with crusted matte, granite, and orogenic gold resource. And most of gold deposits occur as it narrows the zone around this bed, around the north-south direction. Now let's talk about geology of the Phaeon gold deposits. So the gold deposits area is here. So especially mainly covered by the pink color rock units, which mainly compose of the meta-sedimentary rock, such as the quartzite, phyllite, and the schist. And at the edge is the Proterozoic Precambrian age, and Noah Stambados area around there. So we can see some more igneous rocks, as well as downright and also pegmatite buried. And now I'd like to talk about the deposit scale geologies. So this area, so this is a deposit scale geological map. So I already said that the deposit area is mainly covered by the metamorphosed sedimentary rock, as well as quartzite, phyllite, and schist. And the plutonic, the igneous activity is around here, Noah Stambados area, and the host rocks, the thickness of host rocks, quartzite, phyllite, the schist, and range, the 0.153 meter thick, and AU rich, the quartz base hosted in this host rock, and the thickness range 1 cm to 0.1 meter thick, which is periods around the fourth zone. And according to the field observation and the topography, so this nature really look the compressional transitional environment, and the and also in this area the very strongly oxidation condition, because in this area most of the post mineralized the 40s are cutting by this area, say as enormous and river 40 as well. So this photographs showing some evidence of the fee evidence. So you can see that this is really the compressional transitional nature and home mineralized vein hosted in this zone. So we can clearly see the shear plane and also the post mineralization events, especially eastward for the cut, this area. So like a normal 4D, that's why the area is stone is oxidized and brecciated and also the jointed. So this is the stellar image. On this the stellar image, we can clearly see the structural lineament really complicated. And also according to the petrography study of host rock, so the mineralization is strongly, we can identify the shears and hosted structural control mineralization system. So this is methodology. I did the mine research based on this method. First, I did the geological observation, then I took some sample, then sent to the laboratory, then I did some of the laboratory analysis, and final one is for me this research. So I already mentioned that the host rock is the quartzite, phyllite, and schist. Based on my mineralogical study, the host rocks are mainly composed of the chlorite, muscovite, sericite, quartz, and also biodite. Sometimes we can see some high-grade metamorphic mineral like selamatite garnet. According to this mineral assemblage, the host rocks is indicated to the metamorphosis, the gracious spacing metamorphosis condition. That's why the host rock is forming under gracious phase metamorphosis condition. So now I'd like to talk about the mineralization. So actually, the mineralization is vein system. So actually, the vein system is two types based on the field observation. So I could classify the later state veins and early state vein. In later state vein, especially, and the early state vein, especially composed of tourmaline, and later state veins rich sulfide. And also the mineralization area is very appreciated due to the post-mineralization event. So we can also classify some of the remote light bay. And also in this area, in this place, we can see some of gold nugget and nitico.
All right, you have 5 minutes left.
Yeah, now I'm going to talk about the Horus hydrothermal alterations. So based on the XRD analysis and petrography study, Horus hydrothermal alteration is silicification and Phyllis alteration chloridizations as well. And the mineralogical assemblage is in Tomlin Bayali Bay. So we can see Tomlin crystal and also the electron goals, the gold saver. And in sulfide disseminated veins, especially sulfide is chacobarite and barite and also other telluride bismutized mineral. According to the electron scanning microscopes, I could classify gold content, AU atomic percent. So in the remote black veins, gold content really high, and some the 80 to 85, sometimes in remote black vein, almost a 90 atomic percent. So also gold grain is the range 25 to 200 micrometer site. And based on the mineralogical studies, I could identify the mineralization stage. In early stage vein, the Chacobara is common, and gold is the strongly related with the deformation supergene state as a native gold and remove light gold. So, and also contact the fluid inclusion microthermometry. So in Tomlin Bayali vein, I could classify 2 phases, fluid, and also the sulfide disseminated vein, 2 phase, the liquids and vapor phases, fluid. So using some microthermometry to measure temperatures and also salinity range. So in the Tomlin Bayali vein temperature height, the formation temperature is 360 to 380, and sulfide disseminated vein, later state vein is 260 to 280. And salinity range is the 3.5 to 9.5 sodium chloride equivalents for both veins. Based on the analytical methods, some more analytical points I was plotted on this diagram all are included in this area. It's indicated to the load area system. Also, we can say the mesothermal orogenic gold deposit system. So this is I made the images, the deposit models based on my study and also the previous study. The gold deposit is the foamy, the MM bed, and related with this dilation of 4D, northeast, southward direction of 4D, and also some more igneous rock found in this area and also in this area, and gold mineralization forms near this dimensional force zone structure control mineralization system. So this is a discussion and conclusion of my study. All data, review data, and my data based on this data, I was the conclusion. So mineralization is a shears and hosted mesothermal gold vein system, and gobiaric vein are irregular discontinuous store vein, veinless or stranger. So they are controlled by the noise soil shears or structure control. However, this is visible or native grain were failing in the microfracture or the quartz deformed host rock by secondary form hematite and stony brachiated stone. And So those secondary native gold grains might be related to remobilization of primary, the auriferous bed, like is the mineral is the electron, and also other derido-bismutized A-rich mineral, due to the star eval transport mineralization deformation event. So the mineralization in Pyongyang gold deposit is related to both primaries and secondary condition, and the high-grade gold is common in secondary oxidized brecciated zones. Okay, that's all. Thank you very much for your kind attention. Yeah.
Thank you, Mr. Wimpio, for your very informative presentation. Unfortunately, we didn't have enough time for the questions. So if the floor have any further questions, please contact Mr. Wimpio personally. So next, I would like to invite the next presentation is going to be on the possible origin of graphite deposit in Mogok Metamorphic Belt, Single to Beijing area, northern part of Mandalay, Myanmar. And this talk on delivered by the Mr. Han Naisong. I think he is also the staff of the GSE as well. So Mr. Han Naisong, now the floor is yours. Please share your presentation.
Yes, I'm here. Good evening, everyone. Can you hear my?
Yes, we can hear you, but could you take your mask off?
Yeah. I'm out of I'm out of the building. Okay. Okay, no problem.
Thank you so much. So now we can hear you, right? Please continue.
Okay, good evening, everyone. Can you hear me?
Yes, please go ahead.
Okay. Yeah. Today, I'm presenting about the possible origin of graphite deposit in Mogok Metamorphic Belt, Single Beijing area, northern part of Mandalay, Myanmar.
Could you put your phone like near to your mouth, because we cannot hear you clearly.
Okay. Can you hear me?
Yes, please.
Yes. Okay. As introduction, Myanmar and down with the varieties of the potential resource of mineral, such as gold, copper, lead, zinc, silver, and tin, tungsten, and something like that. Among these minerals, the graphite occurrences are the mostly found along Bogot Metamorphic Belt. It's located in the Sengu and Beijing Township and 100 kilometers north of Mandalay City, middle of the country. The regional geological survey and detailed survey has been undertaken by DGSE from 1989 to recent in this area. This is the location of the Beijing Sengu area. You can see here is the middle of the country. The yellow one is indicated to Mandalay Township. Regional geological setting. According to the previous geological data, the Mogok Metamorphic Belt is lying between the Sakai Fault and Shanska Fault, comprised of schist, stalagmite, gneiss, diapside, flocopite, marbles, cut silicates, and granulite. And this locally intruded by discordant pluton and diatic granite and potassium feldspar, bigger-crest granite basilisk. And there are many applied dyes and quasi-feldspatite veins also intruded, and the gold survey bearing quartz vein hosted by gneiss, marble, granite, but are not common along the belt. In the part of Sengut Beijing area, this metamorphic belt comprising the Paleozoic equivalent metamorphic rock and accompanying massive igneous emplacement, which has been very highly deformed by surf, tectonism, and magnetism. This is a location of the Sengut Beijing area and Mogok metamorphic belt. This pink color is referred to the Mogok metamorphic belt, and this green square is referred to Sengu Beijing area. This regional geological map of the Beijing and Single graphite prospect area. The geology is that in the Singu and Vijay areas located within the Mogot metamorphic belt, bounded at the west by Sagai Fort and east by Champlain. The major fault are striking nearly north-south, north-southeast, north-southwest, and in the area. The Sagai Fort is a major north-south striking fault and situated at the western margin of the region and is considered as the possible plate boundary between the Indian plate and Sunderland and is possible marker for Neogen Teutonic region. And the Mogot metamorphic belt lies at the western part of the Shantai block. It's lined at north by eastward trending Momic Fort and west by north-south trending Sakai Fort. This is a tectonic map of Myanmar and surrounding region. The red one is Sakai Fort, and the dashed line refer to Shanskap, and this yellow square is referred to Sengu Tibetan area. And this is another detailed geological map of the Tibetan and Sengu area. Uh, Both in this area mainly found the marble and cut silicate rock, and sometimes found the igneous rock. Rock unit in Sengu area. There, white or crystalline marble in Sengu area is medium to gray and close to pure white or milky white, and flugobite marble, and then diopside marble, and then cut silicate rock, granite, nice iodide granite, and quasi-phosphoric rock and alluvium. This is a detailed geological map of Sengu graphite prospect area. And now I explain about the longitudinal section of graphite deposit of Sengu. You can see here this the vertical made the tree hole, and this black refer to graphite seam. The rock unit of the Beijing graphite progress. In the Beijing area, there only seen white crystalline marble, townside marble, silicate rock, and pegmatite and perforated granite. And this is the detailed geological map of the Beijing graphite prospect. This is a longitudinal section of the graphite deposit in the Beijing area. The class of the graphite deposit. According to the literature review, the class of the deposit is divided into three. They are amorphous, flakes, and vein graphite deposits. And graphite in Singu area. The graphite products mainly consist of calcilicate, flugite marble, diopside marble, crystalline marble, and quasi-phosphate rock, and graphite mineralization is mainly confined in calcilicate rock. The general trend of CS varies from 301 varies from north southeast and dip to 45 to 80 to northeast. The thickness of graphite mineralization zone is ranging from 0.3 to 0.8 meter. The type of graphite is in this area is characterized by small plates, thin flakes, and most of them are amorphous or disseminated as pocket or lenses within calcilicate rock. The graphite bearing outer zone, including with clay, chloride, sulfide, and some portion, quartz fragments, and weather cut silicate fragments. According to the observation of the graphite mineralization in single area, it was deposited within the weak zone of the contact rock which unit such as marble and calcilicate rock. This figure shows the graphite occurrence in single area. You can clearly see the graphite row and graphite export. In graphite in the Beijing area. In the Beijing area, graphite found as an irregular vein, flakes and laser type also occur as vein of fracture failings along intrusive contact of pegmatite with host marble and calcilicate rock. This graphite deposit mainly consists of calcilicate rock, marble, pegmatite, and coarse granite, and generally front of the graphite bearing calcilicate rock is northwest or east and dip to northeast with dip amount between 35 to 60. The average thickness of the graphite seam is in this deposit is 3.75 meter. The occurrence of graphite mineralization is traceable to 450 meter in distance. According to drilling results, the graphite seams of the Beijing area is found as wedge shape and the thickness is not an informal, stable, and due to post-mineralized structure. The same as the host rock are deformed. In both Sengu and the Beijing area, the style of the graphite mineralization is irregular vein, lenses, and pocket type.
Okay,
This
you
is
have
the
5 minutes left.
figure of graphite occurrence in the Beijing area. Now you can see the deformation of the rock and graphitic rock and graphite same in here. Origin of the carbon on the graphite. The three main sources of carbon are from graphite. Carbon from organic materials, carbon from the devolatilization of carbonate minerals, and carbon from metal source. The currently two main genetic models that describe graphite mineralization, the growth of graphite during metamorphic process as known as graphitization and precipitation of graphite from hydrothermal fluid or melt. And then metamorphic graphite is concentrated in the temperature metamorphic rocks, whereas low-grade rocks generally contain the carbonated material in addition to graphite. Graphite occurs as the foliate masses, earthly length, minute decimated scale, or occasionally in six-side tubular crystal. Naturally, the graphite is found in all three types of rock. Graphite is found in the igneous rocks such as iron, nickel, meteorite, type, pegmatite, and infused plutonic rock. The commonest occurrence of the graphite is in metamorphic rocks such as schist, gneiss, metamorphic limestone, although the amount rarely exceeds 10% of the rock many, and the entire rock may sometimes be composed of graphite. At present, a small thin flake used less than 1 to 5 of an inch in diameter distributed throughout the rock or oriented parallel to the foliation in gneiss and schist. The, the graphite occurring in igneous, sedimentary, and metamorphic rocks may be grouped into three types of deposit. The most characteristic group of the deposit is in terms of commercial value in a vein deposit. This type, almost pure graphite is present as vein, lesser pocket, or embedded among the country rocks, which is do not contain any graphite. And graphite from the recrystallization of carbonaceous matter in metamorphosed sedimentary rock resulting from siltstone, shale, limestone, and coal. The graphite-carrying rocks are generally soft and quickly succumb to weathering. Therefore, they are really crop up to the surface, usually being hidden under the more or less thick overburden. Like this, in Singur and Beijing area, the graphite, are mostly found at 4 or 5 meters from surface, and sometimes 10 to 15 meters from surface. Possible origin in Sengu and the Beijing area. In Sengu area, the formation of the graphite in Sengu area is considered as the metamorphic product of the carbonaceous material existing in the host rock. The formation of graphite in Sengu area is thought to be due to the transformation of the original carbon-rich area with calcium-rich band by metamorphic process. In single area, the graphite occurs obviously in contact of calcium and marble. According to the observation of the graphite mineralization in this area, it was deposited within the weak zone of the contact rock with units such as marble and calcium rock. In the Beijing area, the formation of the graphite in the Beijing area is considered as both metamorphic and hydrothermal process. The formation of graphite in this area is also thought to be due to the transformation of the original carbon-rich layers with calcium-rich band by metamorphic process and the precipitation of graphite from hydrothermal fluid or melt. These are the photomicrography showing of the some rock from the Beijing area, and this from the Sengu area. And this
Mr. Han, please wrap
photomicrography
up
showing
your
the nature of
presentation.
graphite and calcite and the thin section. A drilling process. Uh, Totally more than 50 holes were drilled at the Sengu and the Beijing area in this project. And this is a sample profile of the drill hole. Now, let me conclude my presentation. The deposit of graphite in Mogot metamorphic belt are found in Sengu Beijing area, and their areas are trending in north and south direction. The style of the graphite mineralization is irregular vein, lenses, and pocket type. In single area, graphite occurs obviously in contact of cut silicate rock and marble and as small plates, thin plates, and amorphous commodity pockets or lenses. According to Drehol result, graphite bearing zone is irregular, vein-like, and the deposit of graphite may be pocket or landscape. In the Beijing area, graphite found as irregular vein, flakes, and lenses type also occur as vein or fracture failings along intrusive contact of pegmatite with host marble and cut silicate rock. Based on the recent geological investigation, the origin of the graphite mineralization may probably be two main genetic models that are both metamorphic and hydrothermal metamorphic. And then more regional and detailed prospecting is required to learn about the geological process of the origins of these graphite formations, which found in Mogul metamorphic belt, and to look for similar style mineralization in Mogul metamorphic belt. Okay, that's all, and thank you very much for your kind attention.
Thank you very much for the Mr. Han Naisong for your very informative presentation. However, we don't have time for questions, so can we continue to the next presentation? The next one is going to be on a study of mixture between mammoth fly ash and calcium hydroxide for flue gas desulfurization. This talk gonna given by Mr. Kietipong Kamngun, who is a staff of EGAT, or the Electric Generating Authority of Thailand. So now the floor is yours, Mr. Kietipong.
Hello, everyone. My name is Ketipong. Okay, come. Hello, everyone. My name is Ketipong Kamgan from Laboratory Section, Electricity Generation of Authority of Thailand. Today, I come to present a study of mixture between mammoth fly ash and calcium hydroxide for flue gas desulfurization. At first, I will introduce you where is the sulfur dioxide is coming from. The sulfur dioxide is coming from burn high sulfur coal. Because of sulfur with oxygen that cause sulfur dioxide is easily reaction. And lignite in mammoth mine is have high sulfur coal, usually only in mammoth mine because the lignite is very bad coal. It's Roland coal, sorry, Roland coal. Roland coal. Because of the high sulfur dioxide, flue gas desulfurization used to eliminate sulfur dioxide from the process. But from this process, it must use limestone from mountain. This limestone used in slurry tank to feed in the flue gas. So when you use the limestone from environment, so you must deforest and pick up the calcium carbonate from mountain. But this process gives a lot of fly ash. So I think fly ash must do something more than used in cement process. So I find this technique. They change fly ash to calcium silicate with pozzolanic reaction. Pozzolanic came from porcelain. Porcelain is I find something. Porcelain is from the root of pozzoli from Italy. It had a lot of volcano and have volcanic ash. Volcanic ash has high percent of silica and alumina. The easy reaction is silicon oxide include with calcium hydroxide and get calcium silicate. It's really easy method. From this method, It's very easy method. Yeah, but simply method, the condition must be investigated. How sulfur dioxide absorb on calcium silicate? Sulfur dioxide include with water and get the hydrogen sulfide. Hydrogen sulfide can react with calcium silicate and get calcium sulfide. Calcium sulfide is reduced by water and oxygen and get calcium sulfate. So I try to get the calcium silicate by combine in the laboratory. Calcium hydroxide vary from 0.5 gram to 5 gram with coal fly ash, raw coal fly ash, 15 gram with the eye water to 200 milliliter. Stir for 24 hours and filter and get some particle, some white particle, not dark particle like fly ash anymore. Characterization from raw fly ash, it has silicon oxide about 36% weight and 20% weight. Raw coal fly ash in the SEM picture, you will see that it's round and smooth. This might be silicon oxide with aluminum oxide in this particle. Look at the calcium hydroxide from raw calcium hydroxide. Is this particle like a agglomerate particle with needle particle? If you so if you zoom it, I can zoom. It will combine with needle particle around it. Raw fly ash is smooth and wash raw fly ash. Wash by just normally DI water. It's really smooth. At first, I add to 0.5 gram calcium hydroxide. It has some little particle on it, not much. But at 1 gram of calcium hydroxide, you will see the agglomerate on its surface and some needle of it. It's caused the reaction on this and get calcium silicate because from smooth surface, it's not smooth anymore. Some glassy state of silicon oxide was destroyed and get calcium silicate. But when you add more calcium hydroxide, it's cause agglomerate from calcium hydroxide much, but it's not cause calcium silicate. It's just calcium hydroxide stashed on the particle. In this work, it's not finished because it's just start. I try to synthesize calcium silicate from this method. Further works, I have to investigate about time and temperature in synthesize, and more than this, I have to test the sulfur dioxide absorption property. Thank you very much. I have worked only this. Question and suggestion are welcome. Thank you very much.
Thank you, Mr. Kietipong. We still have some time for some questions from the floor. If anyone have. Yes.
What is your ultimate goal of carrying out this research?
I want to use this fly ash to utilize fly ash and use less calcium carbonate from mountain. I know fly ash can be calcium silicate.
But the method is perhaps more expensive than use calcium.
I try to optimum the method. It needs more and more experiment. It's just start the project. Yeah.
All right, any more questions? If not, so please give a big hand to Mr. Ketchpong again, please. Now we come to the last topic of the day. Yes, this one is gonna be the potash exploration in the Nai area, Mahasarakham province, Thailand. And this talk gonna given by the Mr. Nuchit Siritongkam. For Mr. Nuchit Siritongkam, he got his bachelor and master degree from Chiang Mai University in Thailand. And now he is a geologist at the Department of Mineral Resources of Thailand. So Mr. Nuchit, now the floor is yours. Could you please share your screen? Please open your mic. Yeah, unmute it, please. Mr. Nuchit, could you unmute it? Okay.
Everyone can hear me?
Yes, go ahead.
Thank you, Mr. Chairman. Good afternoon, everyone. I'm Nuchit Surirongkam, geologist from the Thailand Department of Mineral Resources. Today, I'm going to talk about the potash exploration in the natural areas, Mahasarakham province, Thailand. My talk is divided into the 6 parts. The first of my presentation will talk about the introduction, and then we move up to the what does the potash mean for Thailand, and then the characteristic of the potash deposit in Thailand. And after that, we will talk about the background of the desert area and a follow-up exploration program by DMR in the 2019. And we will finish with conclusion. I will start with some information about the geo setting of Thailand and general information about the potash. The geotectonical subdivision of Thailand is divided into 4 blocks. The first one is the Chaibumasu block in the west side, the most west side of Thailand. And after that, in the number 2 is the Internon zone, and number 3 is the Sukhothai zone. And the last one is the Indochina block. Why the area that we interest is the Indochina block, which the accumulating of the potash and the rock salt in this area. For the geological map of the Kolat Plateau, Kolat Plateau is comprised of the sedimentary rock of sandstone, siltstone, and mudstone of the represent in the green color. As you see in the picture, you can see in the bright green and olive green and dark green represent for the Cretaceous rock in the Kolat Plateau. And the gray color is also represent the sedimentary rocks was deposited in the pre-Cretaceous, also in Kolat Plateau. For the stratigraphy of the Kolat, the sequence consists of mainly Mesozoic and non-marine, comprised of 6 formations. From bottom to the up, that start from the Hoi Hilat, start from the Nampong, Phukadung, Pavihan, Sao Khua, Phupan, and finish at Phok Kuat. The underline of the Kolat formation by the order log, including the Hoi Hilat formation and Paleozoic marine sediment of the Permian limestone. And Kolat group was overlain by the Aeolian deposit and evaporite deposit in Mahasarkham formation. Move next to the what is the potash. The potash is some of various mine and manufacture source that contain potassium from the evaporite seabed, such as we found in the western of Canada. Also, some natural occurring in the surface water body, such as we found at the Great Salt Lake in the Utah and Dead Sea bordering between Jordan and Israel, contain sufficient potassium to make extract feasible. The most, as we know in the potash mineral, is the first one is the carnallite. The carnallite is a chemical composition composed of the potassium, chloride, magnesium, and H2O. And the other one is the silver. The silver is the colorless in this picture. Chemical composition is composed of the potassium and chloride. And we commonly also found with the blue highlight, which we can see is the blue color in the picture. The potash is used in many countries as the fertilizer to the grow rice, wheat, sugar corn, soybean, and various fruit and vegetables. The potash is major benefit of the potash is the macronutrient in K. Potash used in commercial is available in many color, but not different benefit. In Thai farmer, we believe the good potash should be have the color like should be in the orange color like this. For the resource quality assessment, potash resource are abundant around the world, and estimate world potash resource total about 250 billion tons. Canada and Russia, Belarus are the leading world producers and the supplier with production. In the Kola Tatua, Thailand and Laos, with the estimated resource about 42 billion tons based on the 67 geological covering the area about 4,000 kilometers. In this slide, I would like to review this for showing the potash consumption and the producer. If you look at the potash consumption, you can see the graph is considered rise from the 1970 to the 1980, and then it remains stable until the 2000, and then it increased dramatically again until the 20 and 18. Also in the production, for the top 10 of the exporter, the Canada is the number one of the exporter potash in the world, and followed by the Belarus, Russia, Israel, Germany, Jordan. And for the importer, you can see the Brazil is the biggest importer in the world, and followed by USA, China, India, Indonesia, Malaysia, Belgium. And I would like to notice that if you can see, Thailand is the one of the top 10 of the potash importer. In fact, the potash deposit in Thailand are among the world largest, but remain untapped due to the strong public resistance. This leads me to the next point, which is what is the potash mean for Thailand. Now, Thailand currently import potash to the producer for the fertilizer. Currently, we import the potash 0.7 million tons every year for the production potassium fertilizer. The value at around 10 billion baht. And if you see in the pie graph, you can see the potash consumption. The oil palm and the rice are the large proportion of the potash consumption in the Southeast Asia. And Thailand is the fourth of the largest importer in the Southeast Asia. And for our strategy, and Thailand has long been called the kitchen of the world due to the combination of having abundance of natural resource. Thailand is the one of largest exporting country in the world with food and trade like sweet corn, coconut milk, cassava, durian, rice, and sugarcane, which all of these need to the fertilizer to grow, especially in the potash. In the current situation, the COVID-19 pandemic around the world, Thailand is really lucky because we have a more and more rich natural resource. And this advantage we will through the global crisis by quickly. We believe that. And the next
Mr. Nashid, you have 5 minutes left, so please make it quick.
Okay, okay. For the many study about the collage origin of the potash deposit remain debate. The researcher believe the collage, the potash deposit in collage is the marine origin, and a few scholars, in the other hand, a few scholars believe it's non-marine origin. In the past, more than 40 years ago, the DMR has conducted potash exploration by drilling about 194 drill hole, and we can get a significant potential area in the Chayapum, Nakhon Ratchasima, Khon Kaen province, Mahacharam province, and Udon Thani province, also in Skol Nakhon province. And this is a model of the collage deposit in Thailand. Okay, I will pass for quickly. And this is the area for the natural area. The natural area is located in the Mahacharam province. The rock is composed of the Mahasarakam formation. It consists of potash and rock salt, and is covered by the Putok formation, which are composed of the sandstone, siltstone, and mudstone, and overlying by the quaternary sediments. And Suvanit 2007, they are mentioned this, the potash and rock salt deposit in this area. The structure like a recumbent fold from the 6 historical drill hole. The cross-section, cartoon cross-section like this. And for the 2019 DMR has been conducted a follow-up exploration program covering 28 square kilometers. Our investigation by study land use, district area, boundary, topography, geology, structural geology, and seismic survey was done by Geotechnology Division of DMR, and 3 new hole data was done. And after that, mineral potential area, and we are estimate for the mineral resource. This is the outcrop which we found far from the old new hole, about 6 kilometers to the east. We found the Putok formation which lie in parallel in the ground. And this data showing the seismic cross-section, seismic data. And we got the data, the base rock of Hokwood formation is depth from the ground about 600 to 1,000 meters from surface. And after that, we put the drilling program and 3 new hole, which we represent in the full circle colors in 206, 207, and 208. This is our drilling program. And this is our logging data. We found just only one drill hole. We found the silvinite, and this picture in the left is showing the gamma ray is relation with the analysis, chemical analysis of KTO data. This K27, we not found the potash. We just only found the 2 layers of rock salt. And the last hole, we just found the weathering of sandstone, siltstone, and we finished the drill hole at the siltstone of Putok at the 400 meters. And this is we are relocate at the boundary of the mineral potential after the Suvanich 2007. We extend the boundary to the north, and the background, as you can see, the background is the old boundary of the potential potash areas. And this schematic pictures of the potash deposit in the nature. We believe just only the Mahasarkham layer is the recumbent by the effect of the Putok formation. And after that, the Mahasarkham formation is pushed up like a recumbent fold, and by underlain by the Cokewood formation at the depth 600 to 1,000 meters. And we can recalculate the estimate the mineral resource after the Suvanich 2007. With the Sinwai estimate is about 5 million tons of percent of K potassium about 1 to 46%, and sodium about 5 to 30%, and magnesium less than 3%, and calcium less than 1%. And we also analysis about lithium. Lithium is about 7 to 75 ppm. Okay, to sum up, the exploration potash is essential to our country to support nation domestic demand of the potash for the agriculture purpose. The country's strategy for being the world kitchen and outbreak for COVID-19, potash will be contributing factor to support Thailand to be a global food resource. The natural area is the one of the significant area of potential deposit in Thailand. A follow-up exploration program by DMR, we found the thickness of Mahasarkham formation is about 40 to 100 meters, and underlying basement unit we call the Cokewood formation, depth about 600 to 1,000 meters. The Sinvinai was found at depth about 13 to 60 meters at the K206. The estimated resource approximately 5 million metric tons of Sinwai, and the area should be the further survey for the future exploration. These are all of my talk today. Thank you for your attention.
Thank you very much, Mr. Nuchit. I think because he is the last talk, we may provide the opportunity for 1 or 2 questions from the floor. If anyone have some question, please. Yes, it seems like Dr. Porinya have a questions.
It's very interesting talk. And do you have any isotope, stable isotope information about the salt?
Now we have a cooperation with the Institute Mineral Resource from the CGS, and now we just doing analysis for stable isotope like oxygen isotope, like boron isotope, and I'm not sure, but just doing.
Yeah, after your studies, you may have the result to prove whether it is marine or non-marine.
Yes.
And you have any age determination on that salt?
For this area?
Yes.
For this area, about the age, not study yet. Maybe in the next time for our project cooperation with CGS from China.
To make a further comment for Dr. Pinya's questions. The first is that this stable isotope they got from China can mention about the marine origin. So that's mean there some kind of influx of the of the seawater by some other means or something like that. Another one is you mentioned about the age. As far as I'm concerned, long time ago, people from DMR has a good collaboration with the Germany Institute, Professor Ben Hansen, and he probably got 90 million years or something like that for the rock salt and potash deposit. So if we make some conclusion for this, then it's probably within the Cretaceous period.
Our dating that is on Bamnet Narong.
Yes, Bamnet Narong.
It's not this one.
Not this one, but we probably get the same result, I guess, because that one is even it's overturned. Then it's because of I think it is because of the salt tectonic, not because of the overturn due to the compression strongly. No, but because of the salt tectonic. That's why we get something like this.
Yeah, I would agree with that because of salt doming. It's not a type of ductile deformation as a recumbent fold.
One thing I believe in this area is the center of the basin of the Kolat basin. It can get some more pressure from the around the edge of the basin, and the Mahasakam push up, like overturn, and strong push and strong overturn. As we can see in this area.
Okay, I think this is about time. Thank you again, Mr. Nishit, for. Okay, sorry. It seems like they have another one.
One interesting question you mentioned about silvinite. Is there a ratio between silvite and silvinite in your during program or something? Can you tell us which one is occur more, silvite or silvinite?
The silvite is we was called for the mineral we compose KCl, but in the natural in the drill hole we found we normally found the silvite mixed with halite and silvite mixed with halite was called silvinite.
This one is big, then silvinite is not that good. Is that correct?
No. Is in almost during hole when we found the silvite, but we almost found the silvinite. We not found only pure silvite in the drill hole. The percent of silvite and halite is almost half.
Okay, so the four, please join me, give a big hand again to Mr. Nishit.
Thank you very much.
And also the four, we would like to thank all the presenters today, and please join me to give a big thank to all of the presenters today. Again, please. And now I would like to hand the mic to our secretariat, please.
Yes, thank you very much. Thank you, our chairperson, Dr. Thawatchai Chulawanit, Senior Geologist of the Royal Thai Department of Mineral Resources. And also, I'd like to thank Mr. Samri bin Ramli, Director of Planning and Management, Department of Mineral and Geoscience, Malaysia, for his excellent chairperson for the first session of this afternoon. And that will bring us to the end of the day. And thank you very much for all of the speakers and participants. I think we should have a big hands for everybody who stay up to even now, for the participation. Thank you very much. Before we leave, I'd like to announce that the video presentation for the posters presentation, there'll be more videos showing tomorrow, probably during the lunchtime, after 12:30, between 12:30 to 1 o'clock. And then we'll be trying to show it during the coffee break as well, from 3 o'clock in the afternoon for about 15 minutes. Or else, if you cannot see it, then you can see, we try to put some link for you if possible. And also, I'd like to remind some of the speakers and also all the authors to please submit your CV to our secretariat or to me, so that we can have your record of your presentations and your papers and your expertise. Yes, I think that will bring us to the end of the day. So tomorrow we'll be starting same time, officially at 10 o'clock. There'll be more papers, more interesting issues and things to listen to tomorrow. So for now, I'd like to end the session, and we'll be seeing you tomorrow morning. If you want to test your system, you can come early. Like we will be online sometimes after 9 o'clock. Yeah, before 10. Yeah. All right, we'll see you tomorrow then. Thank you very much, everybody. Bye-bye. Good night.